Warm welcome to all. So this is the chapter which we were supposed to do sometime back, but then because of certain inconvenience, we could not complete this task. So let's take it up today and let's go through the basics of progressions, sequences and series, right? Now, so putting together the progression, sequences and series, it looks little overwhelming agenda, but let's try and see what best we can do through this particular 100 odd minutes. Let's try and see. So I'll get up, keep your pens ready, keep your books ready, keep your pencils ready. Point is no, keep your stuff ready. So let's get started on this. So what I do in the progressions is, of course, to the two very important things. If we put it in the sequence, two important things are arithmetic progression and geometric progressions are much more important from the exam perspective. I'm not denying the fact that, okay, harmonic progression should not be considered. But yeah, if you look at the probability, the questions built on the concept of arithmetic progression and geometric progressions are much higher. Even in geometric progressions, infinite progressions are much higher. In the geometric progression, sum up to infinite terms. The concept of sum up to infinite terms is more fashionable. That's more frequently used than compared with the terms which have the finite number of have as a progression having a finite number of terms. Therefore, let's put it something like this. In progressions, two are very important. One is arithmetic progression. The second one is geometric progression, sum up to infinite terms. The concept, questions built on that concept. Then, of course, we'll go and take a look at questions built on some sequences and series. Let's do the justice. Let's see how best I can take you through these particular concepts. Okay, let's get started with this. Let's go to the arithmetic progression as I told you. Let's start there. Arithmetic progression. Certain basic elements of arithmetic progression. Let's explore first some of the basic elements of arithmetic progression. So which involves the 3 or 4 important parameters there. One, there is an increasing AP. Also, there is a decreasing AP. Decreasing AP. That's important in the sense common difference can be either positive or it can be negative. For example, if I have my first term, if I have my first term, I have my second term, let's say there is a third term, there is a fourth term, and so on. Let's say if I have these terms, right, fourth term, and so on, if I have them. These are the terms. So what I'm trying to say is, okay, is there always a fifth term? Yes. Is there a sixth term? Yes. There is no end to that, right? Fifth term and sixth term of a progression. See, for example, my first term is 2, second term is 5, and the next term is 8 and 11 and 14 and 17 and so on, if I keep writing it like this. So we all understand that, okay, is there a seventh term to this? We have. After somebody writing seventh term, can somebody else can write the eighth term? They can. So therefore I need to conclude it saying that, hey, I write 6 terms and let's make a study built on this. So what is the first thing that I want you to understand is, this is the arithmetic progression in which the common difference is positive. How do I find the common difference? We call it as D. Common difference is either I can do it T2 minus T1, or I can take this as T3 minus T2, or there is a rule, right? That's a rule book that's defined, T3 minus T2, or I can write this as T4 minus T3 and so on. All right, it's clearly defined. I cannot do all right. Hey, can I also do this as T1 minus T2? No. T1 minus T2 cannot be done. It should be T2 minus T3 or T3 minus T2 or T4 minus T3 and so on and so on. It goes on and on and on. So therefore you realize that each one of them is nothing but each one of them so each one of them is nothing but 3 in this case. That's nothing but the common difference. Had I written the same series in the backward fashion, in the sense, hey, had I written this as 17 here, 14 here, 11 here, and 8 here, 5 here, and 2 here, assume that this is another series. So another series. So in this case, I would have done the common difference. Had I taken the same common difference D, the other side I am writing common difference D, I would have got my response as -3, because it's a decreasing series. Right now, this is a decreasing AP and this is an increasing AP. There is an increasing AP and there is a decreasing AP. Increase and decrease. Right. So therefore, there's nothing but decreasing AP I'm talking about. Good. So first, I need to be mindful that, okay, I might encounter increasing AP, questions based on increasing AP, or there can be questions based on decreasing AP. Number one. Point number two. That's the first point. Second point, let's understand this. How do I write my nth term? How do I understand there is my, how do I write my nth term of this particular series? Likewise, if I ask you that, hey, why don't you tell me what is the nth term of this particular series? Fine, generally we write the first term as A. We generally write the first term as A, and then we'll write the common difference here. See, this gap is 1D here, therefore you write this as A plus D. There is another gap here, second gap here, therefore you write this as A plus 2D. Likewise, in the sense, when you're writing writing your third term, you encountered 2 gaps. Similarly, when you write your fourth term, you encounter 3 gaps, right? Now, but the term is fourth term, but the gaps are only 3 gaps. Thereby, you would say that, okay, when I write my nth term, a plus n minus 1 gaps will be there. That is n minus 1d. That's the nth term. Okay, we are all comfortable. We know about it, but let me not take it for granted. Let me put it to perspective. Nth term is written as a plus n minus 1d. What is a first term? What is n minus 1? Number of gaps. What is the value of each gap? N minus 1 is number of gaps. What is the value of each gap? That is d. First term plus n minus 1 gaps. I need to add. Each gap is nothing but a value called d, common difference. That's how I get my nth term. Okay, that's point number 1. Second one, how do I find my arithmetic mean? How do I find my arithmetic mean? If I want to understand that, hey, what is the arithmetic mean? Arithmetic, how do I find the arithmetic mean of the given series? So there is the multiple ways to do this. There is multiple ways to. That's my point number 3. What are the multiple ways? You could say that, hey, I will add my first term and the last term. In this case, let us take an example of 6 here. I can add the first term and the last term divided by 2. That becomes my arithmetic C. First term and the last term, well, T1 plus T6 divided by 2. That becomes my arithmetic mean. This can also be written as second term and the second last term divided by 2. That is also arithmetic mean. In the sense, what I'm trying to say is that you can take the first and the last. You can use the first and the last, you'll get the arithmetic mean. Second and the second last, you get the arithmetic mean. Third and the third last, you will get the arithmetic mean. All these are the ways to find the arithmetic mean, which is nothing but 19 divided by 2. Which is nothing but 19 divided by 2. Which one you do does not matter. Alright, 2 plus 17 by 2 is fine. 3 plus 14 by 2 is fine. 5 plus 14 by 2 is fine. Whichever the numbers that you take, it all turns out to be 19 by 2, which is nothing but 9.5. So point is, arithmetic mean can be found out in multiple ways. It can also be found out as, no, I will add all the terms. That's also fine. T1 plus T2 plus T3 up to T6 divided by 6. Hey, why 6 this time? Why you are dividing by 6? Because you added all 6 terms. Hey, why did you divide by 2 here? Why did you divide by 2 here? Because you added only 2 terms. Choice is yours. You want to add 2 terms or you want to add 6 terms. You have that particular choice there, right? You have that particular choice there. So that's my point. My point here is, second point is, arithmetic mean can be found out in many ways. Many ways. Okay, point number 3 is the third point. Well, last point, sum up to n terms of the series. How do I find sum up to n terms of the series? Take the first term and take the last term divided by 2. What do I get here? Arithmetic mean you get. Arithmetic mean into number of terms gives me the sum up to n terms of the series. If I know average, if I know how many terms are there, I can find the sum of that particular series. Right now, therefore, that's one way of doing it. Hey, instead of this, can I also say that, no, I will take the second term and the second last term, Tn minus 1, that second last term. Second term plus second last term divided by 2. Will that work? Yeah, that will also work. This becomes arithmetic mean into n. Technically, what I'm trying to say is, sum up to n terms. Sum up to n terms is nothing but arithmetic mean into number of values. Alright, arithmetic mean, that's arithmetic mean into number of terms, right? So therefore, that gives me sum up to n terms of the given series. Okay, so what is, therefore technically we write this as, what is T1? So you write it as T1 plus Tn divided by 2 times of n. So if you resolve it, you will get this as n by 2 times of 2a plus n minus 1 times of d. That's simplification, right? That is sum up to n terms of the series. Okay, whichever way that you understand, I want you to remember sum up to n terms. I want you to remember, how do I find my nth term? I want to find out that, okay, how do I find the arithmetic mean? Arithmetic mean can be first and the last term by 2, first, second and the second last term divided by 2. Sorry, here you should write 5 here, right? Now, second and the second last term divided by 2, third and the third last term divided by 2. That positioning, all right, that sequencing or that positioning is kind of important, right? Okay, let's keep these things in mind and let's go ahead and unleash the questions. Let's do some questions built on this. Let's do some questions. As we do the questions, I will also add few more properties to this. So let's do the question. Let's go to the first one. Let's do a small drill. The words would come there. It will not be given as T10 is equal to 7. You don't find something like that. You don't find something like that. So this is just for my and your reference, right? Now, it's only for my and your reference. So what is given to me here? So it is said that the 10th term is 7. Therefore, what is sum up to 19 terms? Fine, we can do this in the traditional manner as well. But I want you to focus on the way I let now. So I want to see this particular thing. The author is interested in sum up to 19 terms of the series. Therefore, what do I have? I have the first term, I have the second term. Likewise, dot, 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 I have up to 19 terms. Okay, sum up to 19 terms is what I require. I need to add them. What is given to me? Between all this, author said that, look, the 10th term is nothing but 7. 10th term is nothing but 7. look friends, all right, now this is very interesting phenomena what is given. If 10th term is nothing but 7, which means how many terms are there before this? There are 9 terms before this. There are 9 terms because it's the 10th term. So there will be one T9 here, 9 terms before this. Then you start from 11. So therefore you would say that, okay, how many terms are there here? 9 more terms after this. There are 9 more terms after this. Okay, just like we did before. Yeah, what if there are odd number of terms in the series? What if there are odd number of terms in the series? That is, if I have T1, T2, T3, T4 and T5, if I have odd number of terms in the series, the middlemost term is also called as arithmetic mean. Why? Because I can add the first and the last and divide by 2, second and the second last divided by 2. What about the middle term? There is no 2 middle terms. There is only one middle term. Therefore, middle term divided by 1. Alright, because first and the last divided by 2 because you are adding 2 terms. Second and the second last divided by 2. Why 2? Because you are adding 2 numbers. Therefore, you are dividing by 2. Yeah, what if the moment I reach the middle number, there is only one number? One number divided by 1. Therefore, that's arithmetic mean. So that is what precisely happened here. Therefore, technically, author is trying to say that, look, I am telling you that arithmetic mean is equal to 7. Mean of 19 numbers is 7. Therefore, what is sum of 19 numbers? Simple answer is going to be 19 into 7 because number of terms into arithmetic mean is the sum. Sum of 19 terms is nothing but arithmetic mean. Let arithmetic mean into n. So what is arithmetic mean of these 19 numbers? It is 7. Yeah, how many numbers? 19 numbers. Therefore, you are saying that this is nothing but 133. Right? 133 is nothing but the sum required. Okay, my point is just be mindful. Just don't go a traditional approach every time. Just watch out. So what is the kind of stimulus that is given to you? Sometimes because these become the intermediate steps of some of the questions that we are going to solve, right? So therefore, we need to develop that understanding as to what is the data technically, right? So when somebody is saying that arithmetic mean of the 19 numbers is 7, I should be able to understand that, okay, man, you are trying to tell me that arithmetic mean is 7. I should not simply read it as some other 10th term is 7. Fine. The value of the 10th term is 7. In other words, author is also trying to say that arithmetic mean of 19 numbers is also 7. So therefore, I need to correlate them properly there. This is the mind window. In the mind window, this is running. This is what is running in the mind window. It is running like this undercurrent. I'm not saying that you should write all of this. No, but it is running at the background of your mind, right? Okay, fine. All of you would have got that particular point. Let me go to the second question, friends. Let me go to the second question. Let's understand the second question based on the similar lines. Now listen to the second one here. Second one, let's try the second one. So fourth term is 24, 22nd term is 76. Well, let's find the 13th term, very good. And second one, sum up to 25 terms. This is important. Let's start here. Sum up to 25 terms means what? There may be many terms in the series, but author is interested in the first 25 terms. Now listen to me. If there are first 25 terms, it will go something like this. There is a term 1, there is a second term, there is a third term, there is a fourth term, dot, 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 it goes on, right? Then you have the 25th term, you have the 24th term, you have the 23rd term, you have the 22nd term, and so on, dot, 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 middle terms are here. Now look, how do I find the arithmetic mean of this particular series, friends? How do I find the arithmetic mean? I can add the first and last divided by 2, or I can add the second and second last divided by 2, or I can add the third and third last divided by 2, or I can add the fourth and fourth last divided by 2. Perfect. That's what he is precisely giving me here. He has given me the fourth term and he has given me the fourth last term. He is saying that, hey, I'm telling you the arithmetic mean is easy to find. I'm giving you the fourth term and the fourth last term. So therefore, what is arithmetic mean? Fourth term and the fourth last term. In this case, the fourth last term is nothing but the 22nd term of the series. Fourth last term divided by 2 becomes the arithmetic mean, that is 24 plus 76 divided by 2, that is 100 divided by 2 is the arithmetic mean. We can write it as 50. There is no harm there. Technically, by giving these two informations, author is saying that, look, I am telling you what is the arithmetic mean out there. Arithmetic mean is nothing but 50. That's what author is trying to say. Now look at this. If there are odd number of terms in the series, there is a first term and 25th term. What is the middlemost term here? 13th term. 13th term is the middlemost term. Why do we say that? There are 12 terms which come before this. There would be 12 terms which come before this. And there would be 12 terms which come after this. There would be 12 terms which come after this. Well, therefore, all in all, there are 25 terms here. There is one middle term. This middle term is also nothing but arithmetic mean, which you already found out. Therefore, this is also equal to, right? This is also equal to the 13th term. So you got the answer. 13th term is nothing but 100 by 2, which is nothing but 50. Already you got that answer. Technically, T13 is nothing but I'm asking, why don't you tell me the arithmetic mean? Find sum up to 25 numbers, therefore. Sum up to 25 numbers is nothing but what? Arithmetic mean into n. Alright, what is arithmetic mean? 100 by 2. 100 by 2. That's nothing but 50. What is n there? N is nothing but 25 terms. N is nothing but 25 terms. Therefore, that becomes 1250. That is the sum up to 25 terms of this series. Okay. Point is, I want you to understand little bit of lateral thinking, in the sense, don't read it plainly like fourth term is this. When you read fourth term is this, of course, you can write the fourth term as a plus 3d is equal to 24. No harm in writing. You can write the 22nd term as, or you can write this as a plus 21d, alright, which is also equal to 76. I'm not saying there is any harm in writing this. My point is, why don't we think properly about the numbers which is given? Why can't I construct something in my mind? If I can get that construct properly in my mind, it becomes a mental problem. You don't have to draw this diagram for me, right? You don't have to draw this diagram. There is a construct in your mind. You are trying to understand that, okay, this is the fourth term, this is the fourth last term. So you are getting that construct, therefore you are easily getting those answers within no time. You don't have to write any formula to figure out what is A, what is D. All that might not be required there, right? That's my point. In the sense, be sensible. Keep your eyes and ears open to the stimulus, so that you will understand the information a lot better and faster. Okay, that's about the second question here. So all of you are following me, I guess. I'm guessing that, okay. I'm hoping that everybody is following here. Let's go to the third question here. Let's go to the third question. All these are nice warm-up drills from your high school. Nice warm-up drills, what I'm trying to do here. Let's go to the third question. Sum up to 4 terms is equal to sum up to 5 terms. Therefore, the question is, why don't you tell me what is sum up to 9 terms? Which means there are 9 terms in this particular series. Ultimately, there are 9 terms. Right? Ultimately, there are 9 terms. Now, what is given to me? Sum up to 5 terms. Let me write sum up to 5 terms. How do I write sum up to 5 terms, friends? T1 plus T2 plus T3 plus T4 and T5. I can write it like this. Sum up to 5 terms. All it now is equal to what? K. Let us call it as K. Sum up to 5 terms. Let us call something as K. Okay. Then second one, sum up to 4 terms here. So what is the, why I'm doing sum up to 5 terms and sum up to 4 terms? Because that is what is given to me. 5 is given, 4 is given. So now let me write what is sum up to 4 terms. That is T1 plus T2, T3 and T4. T3 and T4. What is this? This is also equal to K. Who said? Author only said they're equal. Alright, they're equal. Okay, now what do I do? Solve. Let me solve them. Let me solve. Just like a 2 equations, let me solve. If I solve, these things get cancelled. Assume that I'm subtracting the second line from the first line. Therefore, T5 is equal to what? KK0. T5 is equal to 0. Now think about this, friends. When you're writing sum up to 9 terms, the T5 is the middle term, right? T5 is the middle term. You have T1, T2 like this. Then you encounter T5. Then you go with T6. Then you write up to T9. Yeah, what is this T5? Middle term. Why? Because there are 4 terms before this and there are 4 terms after this. Therefore, T5 is the middle term. That is nothing but the arithmetic mean. Now you are trying to say that, okay, the mean is 0. So therefore, what is the sum? Therefore, sum of 9 terms is nothing but arithmetic mean into number of terms. Number of terms is 9. So therefore, you are saying that 0 into 9, which is equal to 0. But the third one is in fact a property, right? Property. What is that? Sum up to m terms is equal to sum up to n terms. Well, given sum up to n terms is equal to sum up to n terms. Then sum up to m plus n terms is equal to 0. I'm sure all of you have done this in high school. If not high school, or if you have taken math as a subject in the 11th standard, you would have surely revised it once again while you are doing your 11th standard. This is one of the standard properties, right? This is one of the standard properties. If sum up to m terms is equal to sum up to n terms, then sum up to m plus n terms is equal to 0. It need not be m and m need not be 2 consecutive. Anything it could be. You may say that, okay, sum up to 10 terms is equal to sum up to 20 terms. Therefore, sum up to 10 plus 20 terms. Answer is 0. That's it. Answer 0. Sum up to 30 terms is simply going to be 0. That is it. Okay, yeah, fine. That's one of the properties out there. It's one of the properties out there. I showed you how to write some of the steps if it is required. Let's go to the next one. Fourth one, friends. Let's go to the fourth one from here. All right, so all of you got the third property, I guess. All of you got the third property. Let's go to the fourth one now. With that understanding, let's go to the fourth one. Let's quickly go on to the fourth one and try and answer. Okay, fourth one. Fourth times of the fourth term is equal to 5 times of the fifth term. Therefore, find the value of the ninth term. Okay, how do I write it? 4 times of the fourth term. What is fourth term, friend? A plus 3d is also equal to 5 times of the fifth term. That is a plus 4d. That's fifth term. All right, now both are equal. Okay, let me simplify them. So therefore, you would say that a All right, 4a and 5a, that becomes a, and there is a 12d and there is a 20d. All right, now therefore, all right, now so you get it as 8d. What did I do? I just simplified this line is equal to 0. All right, a plus 8d is equal to 0. Oh, what is a plus 8d, for example? What is, all right, for that matter, what is a plus 8d? Ninth term. Therefore, you are trying to say that ninth term is 0. Therefore, ninth term is 0. So there was a property for this, right? Now, what property for this? M times of the mth term is equal to n times of the nth term. Well, given m times of the mth term is equal to n times of the nth term, then m plus nth term, then m plus nth term is 0. Therefore, m plus nth term is 0. That's another property that you would have learned. Okay, it's good to remember property. It is not, it is a past, but at least I'm also doing a warm-up by writing things like this. I'm just also teaching you how to use the nth term, mth term, all that stuff. All right, now we are also learning to write like that. That's also another point there. Fine. Let's go to the fifth question. Let's go to fifth question. Sum up to 4 terms is equal to 5 and sum up to 5 terms is equal to 4. How do I write sum up to 4 terms? T1 plus T2 plus T3 plus T4. Let me write the second one plus. Sum up to 5 terms I'm writing, friends. Sum up to 4 terms and sum up to 5 terms is equal to what? 4. So what did I use? I used sum up to 5 terms to start with. Okay. Then sum up to 4 terms is T1, T2, T3 and T4. Sum up to 4 terms is also is equal to 5. Solve them. Let me solve. Let me solve here. Let's solve this. So when I solve, what do I get? All right, when you solve, all right, these terms get cancelled. In fact, I'm subtracting the second one. You say that the fifth term is equal to minus 1. Therefore, sum up to 9 terms is equal to arithmetic mean, all right, into n terms. Say what is T5 here? T5 is nothing but the arithmetic mean, my friends, because it's a middle term. If there are 9 terms in the series, what is fifth term? Fifth term is the arithmetic mean. Arithmetic mean is minus 1 into 9. Therefore, the result has become what? Minus 9. Okay, what did you learn? The standard result for this fifth question. There is a standard result, right? Yeah, standard result. Sum up to m terms is equal to n. Sum up to m terms is equal to n, and sum up to n terms is equal to m. Given this, then we can find that sum up to m plus n terms is equal to minus of m plus n. Minus of m plus n. Sum up to m plus n terms is minus of m plus n. Likewise, you also would have learned another 3 or more results, but I hope all it knows. So what I'm trying to say is I'm not asking you to mug up the result. I'm saying that, okay, given questions like this, let us learn to write like this. Let us learn to write like this, and let's try to solve simple as that. Let's learn to write some things. So that was the point with 3, 4, 5, just to help you to recall on it what you have done in the progressions technically, right? Okay, fine. So let's go to some of the applications now. I think I did sufficient revision here. Let's also do, okay, maybe one of the important points here with this particular question. First, listen to me before I do this. Yeah, how do you learn to assume 3 things in an AP if there are 3 terms in an AP? Because this comes quite often, right? Yeah, 3 terms in an AP. How do you assume? You all learned that. Okay, generally, how do you write 3 terms in an AP? We write a here, we write a plus d here, and we write a plus 2d here. If I write the sum, why don't you tell me the sum of these 3 terms? Then it would become 3a plus 3d. 3a plus 3d. Assume that sum will be given to us, a value of sum will be given to us, but I'll end up with 2 variables. Therefore, what did you learn? You learned that the first middle term, I call it as a, right? So you generally call the t2 as a. Therefore, t1 would be d less than a, and t2 would be d more than a. Now you write the sum, my friends. When you write sum, you get 3a. Hey, why do I get 3a? Because d and minus d get cancelled. Alright, when I add the sum t1 plus t2 plus t3, I get 3a. So if the value of sum was given to me, some value of sum is given to me, 3a is equal to something. Therefore, I start by getting the value of a from here. Alright, that's our advantage. Okay, what was my point? My point is simple. If there are odd number of terms in the AP, assume the middle term as a, and then write the other terms, and then write the other terms. As you go backward, you will subtract a d. As you go forward, you write a d. Am I right? Yes or no? So okay, let us do it for 5 terms. Although it is rare, they generally don't give us 5 terms. Assume they gave 5 terms. Assume, all right, now so 5 terms here, and the sum was given. Assume the sum was given to us. So therefore, how do I start this particular problem when the sum is given and there are odd number of terms in the series? So you would say that the middle term, I call it as a, and as I go backward, I keep subtracting d. All right, as I keep subtracting d from here, because I'm here, this is my starting point. As I go forward to the right, I write this as a plus d and a plus 2d. Advantage is what? When I write the sum, it becomes 5, it becomes 1 variable, right? Because all the d's get cancelled. All right, minus 2d gets cancelled with plus 2d, minus d get cancelled with plus d. All right, thereby it becomes 5. That's important phenomena there. What if there are even number of terms, friends? What if there are even number of terms? Assume that there are 4 terms in the series. Assume that there are four terms in the series. Generally 3 and 4 is what you see in the exam, right? Yeah, so what you see is, okay, now then maintain a gap of 2d here, in the sense, hey, keep a assume the two middle terms. There are two middle terms here. So what you would do is, one of them you call it as a minus d, other one you call it as a plus d. Call one of them as a minus d, call one of them as a plus d. That's important there, right? Call one of them as a minus d, call the other one as a plus d. So therefore, what is the gap that you are maintained now? 2d is the gap you are maintained. That's fine. Common difference is common difference. There is no hard and fast rule that d should be the gap. Gap should be constant, in the sense, how much gap I should maintain here? Maintain 2d. Therefore, this you write it as a plus 3d. A plus 3d. Okay, backward, how much gap I should maintain here? 2d. The gap has to be constant. Whether the gap is called x or d or 2d does not matter to us, right? Yeah. Okay, therefore you say that the gap here, therefore this value is going to be a minus 3d. Advantage is what? If the sum was given to us, the sum becomes simply 4a. 4a is equal to something, because minus 3d plus 3d, they get cancelled. Just remember this portion, right? Now this is important to us, and this bit, last bit, is important to us, right? If there are three terms in the AP, how do we assume the terms? If there are four terms in the AP, how do you assume the terms? If I understand these two, that is primarily important to us. Of course, this is secondary importance. Five terms in the AP is secondary importance, because you don't find that more often in the exams. Fine. Let's go to this question. Therefore, let's go to this particular question here. Let's take a look at this particular question. Sum of three terms in AP is 18. Sum of three terms is 18, and the product of the first and the third is 20. Question is, what can be the common difference? Therefore, what can be the common difference? All right, what is given to me? So he's saying that product, sum of three terms in AP. That's a point here. Sum of three terms, odd number of terms. Therefore, you would start by saying T1, T2, T3, and their sum is given to me. What is sum here? Sum is nothing but 18. So what did we say? We have to start with the middle number. Fair enough. This is A. Therefore, what is this? A minus D. Therefore, what is this? A plus D. A, what is the sum, my friends? The sum of this is nothing but 3A. Why? Plus D and minus D gets cancelled. If you add T1 plus T2 plus T3, what do I get? I get 3A. 3A is equal to 18. Therefore, what is A here? 6. Therefore, what is A here? 6. Fine. Therefore, what you are trying to say? This is 6, and this is going to be 6 minus D, and this is going to be 6 plus D. Okay, so from here, what did you find out here? So what did you find out? Already you found out what is the middle term. But the point is, he wants the common difference. He is not interested in the value of the middle term. TA is the middle term. Middle term is 6, but he is interested in D. He's saying that, okay, why don't you tell me the value of D? So what is given? It's also given to me that the product of the first and the third term, T1 into T3, it's also given to me that T1 into T3 is equal to 20. Product of these two terms is also is equal to 20. What is the T1? 6 minus D. What is T3? 6 plus D. This is equal to what? 20. That's of the form A plus B. A minus B is equal to 20, right? A minus B, A plus B is 20. Therefore, 6 square minus B square is equal to 20. In other words, you say that D square is equal to 4. D square is equal to 16. Or D square is equal to 16. Thereby, D is equal to, D square is equal to 16 implies that D is equal to plus or minus 4. Take the first case. Let the value of D be plus 4. Because I said that there can be increasing AP and there can be decreasing AP as well, right? Yeah, so that's what I meant here. Okay, you got the answer. What can be the common difference? Common difference can be either plus 4 or minus 4. Just I'm extending a little bit, saying that, okay, what if it is plus 4? Then the terms are 2, 6 and 10. Well, that is what you mean by saying that, hey, D is nothing but plus 4, increasing AP. Therefore, the values 2 and then 6 and then 10, they are in the increasing order. Similarly, I can have a decreasing AP as well. D is equal to minus 4. Put D is equal to minus 4. You get 10 here, you get 6 here, and you get 2 here. What has happened now? This has become a decreasing AP, right? Now, so both are possible. Therefore, what can be the common difference? It can be either 4 or minus 4. Okay, 4 or minus 4 is not important. What is important to me here in this question is how to assume the terms, when there are odd or even number of terms in the AP. That's what's important about this particular question. Okay, now this covers the fundamentals of this particular progression, arithmetic progression. This covers the fundamental. Let us go to applications for some time. Let's get on to the applications for some time. Here is the first question. Take a minute, think about it. Take a minute, just take a minute, think about it. I'll come back and we will solve it. Just take a minute, because basics are dealt now. Take a minute, let's go through this. Okay, guys, let's do this together. Let's do this. So there are technically, if you see this, okay, what is this particular series? Is this AP or what? Alright, you get a doubt about it. So now this are the okay. We did the traditional series. What I'm trying to say is let's expose ourselves to the varieties. Yes, it's an AP series, but the point is it's an alternate series. There are two AP series here. Of course, there are 200 terms, no doubt, but there are two AP series here. What are those? Alright, now alternate 1, 6, 11, and if you go on like this, alright, that red one, that is one series. That is, there is one series, there is one arithmetic progression 1. Yeah, what are the terms of this? The first term is 1. The second term is 6. All right, these are the terms here. 1, there is a 6, and there is 11. These are the terms you are adding them. That's it. Arithmetic series is not with a plus sign. I'm not saying series as a plus sign here. Sum of the AP1. First AP1, it looks like 1 plus 6 plus 11 and so on. Okay. There is another series as well. There is a 4, 5, 6. All right, now there is a sum of the second AP series. Yeah, what is the second AP series here? That starts from 4, 5, and 6. So how many terms are there in the first series? 100 terms are there. There are 100 terms. How many terms are there in the second series? There are another 100 terms. Say why you are saying 100 terms? Because totally 200 terms. Alternate series. One term belongs to the first AP, second term belongs to another AP, another term belongs to alternate, right? Now therefore naturally there would be 100 terms from the first AP and 100 terms from the second AP, because it cannot happen that 50 terms belongs to the first AP and 150 terms belongs to the second AP. No, well, it's an alternate, it's a switch. Therefore, what is the final AP here? Now, so therefore, sum of the final AP, that's a combined AP, right? Sum of the combined arithmetic progression is what? Alright, it's nothing but I can add up these two terms. I can say that, hey, this is 5. I can add up this, alright, this is 11. I can add up this, alright, now this becomes 17. I can add up this series like this. How many terms will be there? 100 terms. Hey, why you are saying 100 terms? I'm clubbing two terms at a time. So is this another AP now? Yes, that's another AP. Now think about this. What is the common difference, friends? 6. Yeah, what is the common difference? That's 6. Yeah. Therefore, you got the new common difference. Now, how did you get the new common difference as 6? Similarly, so look at the common difference of the first series, 5. Look at the common difference of the second series, it is 1. Therefore, what is the combined common difference? The combined common difference is 6. So this is what they do sometimes to con us. What they do is they'll not give one particular series in the right order. They squeeze up multiple series. All right, now thereby they may create some confusion to us. Simple. All right, now so what I will do? I will solve for this now. Therefore, I will solve for this. Do I know the first term? Yes, I know. Do I know the common difference? Yes, I know. Therefore, can I find the sum up to 100 terms? I can find, because we know that sum up to n terms of the series. Sum up to n terms is nothing but n by 2 times of 2a plus n minus 1d. 2a plus n minus 1d. Yeah, how many terms are here in the combined series, my friends? There are 100 terms. There are 100 terms. Therefore, n is what? 100 by 2. You don't take 200 by 2, all right? Because there is a combined series. I'm talking about the combined series. In the combined series, I'm making this study, okay? 2 times of a. What is the first term here, friends, in the combined series? 5. Therefore, 2 times of 5 plus n minus 1. What is n minus 1? 100 minus 1, because there are 100 terms, that is 99. Yeah, what is the common difference of the combined series? Common difference of the combined series is 6. Common difference of the combined series is 6. Okay, therefore we can simplify this. Therefore, sum up to 100 terms of this series is nothing but 50 times of 10 plus 99 times of 6. We can simplify this, and which becomes our answer. Which becomes our answer. Okay, my point is not simplifying this and not simplifying this. My point is, okay, so sometimes it can be simple AP series, but the way they present it can be little trickier, or the presentation may be trickier. Let's be little mindful of that. Alternate series, just remember that. Be mindful about looking at alternate terms. Be mindful about looking at alternate terms. This alternate is something which is very frequently used in the exams in various formats. Sometimes you'll be doing a number series, therefore the alternate comes in the picture. The word alternate is important. Just like in time and work also, you said that people coming on alternate days to do the work, etc. This alternate is very frequently used phenomena, right? Alternate is very frequently used phenomena, because all it now, so generally in the works as well, work environment as well, this alternate all it now plays a very important role, right? Now, so some all it now, so there is a concept of Monday, Wednesday, Friday, and there is a concept of Tuesday, Thursday, Saturday. This concept exists. This alternate concept quite frequently exists. All right, thereby all these alternate terms, alternate things, all right, this alternate is kind of drilled logically. It is kind of drilled in the human brain. All right, that's my whole point out here. Just think about this word called alternate. That's my point. Fair enough. Let's go to the next one from here. Let's move on to the next one from here. Let's take a look at this question. Let's take a look at this question. Take 30 seconds, not much time. Just take about 30 seconds. Think about it. Take 30 seconds and think about it. Yeah, good. Okay. So for convenience, let me write this in the reverse order. This can be done in many ways. I'll let know whenever the numbers are a little larger or whatever. One way to write this is for the convenience to explain it to you. Let me put this in the reverse perspective, my friends. All right, now so let me write this as 2999 whole square minus 29 2998 whole square plus every odd number would have a positive sign, right? Yeah, therefore 2997 square, right? Then you would have minus 2996 square. Every even number would have a negative sign, right? And this goes on, this kind of goes on here. You may say, okay, let me write a couple more. 2995 square minus 2994 square, right? 2994 square. All right, likewise you can go on and on and on. Then you may say that minus 3 square, then find my plus 3 square minus 2 square, and finally you write it as plus 1 square. Fair enough. Okay, if you just only look at this bracket, this is of the form a plus b, a minus b. Right now, a square minus b square, 2998. Or just underlined one only. Let's take two terms at a time. Let's resolve. 2999 whole square minus 2998 whole square. Fine. So this is of the form a plus b and a minus b. Alright, this is of the form a plus a square minus b square. A square minus b square can be written as a plus b and a minus b. Okay, let me write a plus b first. So let me write a plus b first. If I'm writing a plus b, I'll be writing this as 2999 plus 2998. That is a plus b. Hey, what is a minus b? 1. Therefore, I will ignore. Already a minus b is what? A minus b is 1. 2999 minus 2998. I can multiply by 1, no problem. Into 1. Already into 1. That's what you are writing. Like plus. So let me take this now. Let me take these two terms here. Again, they are of the form a square minus b square. A square minus b square. Therefore, what? A plus b, 2997 plus 2996 into 1. All right, into 1. Okay, plus. All right, plus. Now take a look at this. These again of the form a square minus b square. You can write this as 2995 plus 2994. All right, into 1. All right, into 1 plus. All right, now likewise I can come till here, friends. I can come till here. So when I write this 3 plus 2, all right, this is nothing but 3 plus 2. 3 minus 2 is nothing but 1. All right, plus finally I have 1. Okay, now resolve it, my friend. This is nothing but z. All right, now let me just simplify this. Therefore z is nothing but, let me write it because this one does not matter, right? So continuous 2999 plus 2998. Then this plus, I'm just copying it down. So copy this. This becomes 2997 plus 2996. Okay, plus copy this down. So that is 2995 plus 2994. Let 94 plus dot dot dot, and this series goes on. Finally, what you are writing, 3 plus 2 here. 3 plus 2 into 1 is 3 plus 2, and then this one finally here. Nothing but this is a summation series. Take a look at this. It's a beautiful summation series. So could look it backward. All right, now 1 plus 2 plus 3 like this up to 2999. Therefore, what is z? Z is nothing but summation 2999. Sum of first 2999 natural numbers. All right, which is nothing but, what is sum of first and natural numbers? Sum of first and natural numbers is n into n plus 1 by 2. That is sum of first and natural numbers. We'll be knowing some of the squares of first and natural numbers we know. Some of the cubes of first and natural numbers we know. So likewise. So therefore you would say that n into n plus 1, 2999 into 3000 divided by what? 2. That is the value of z. We can simplify this. That's not a worry. But we can simplify this, n into n plus 1 by 2. See, my point is not again simplifying this. This is pretty simple. Multiplying by 3 and dividing by 2 is not a problem there. That's not the idea. The idea here is, so how do I kind of look at the questions in a different perspective? Now, is this an AP here? When you looked at this particular one, is it also an AP? Yes, it's an AP whose common difference is 1. It's an AP whose common difference is 1, provided you look at the AP in this direction. Alright, if you look at the farther direction, it will become minus 1. So, but if you look from here, let me just look here. Z can be written in the reverse direction also after this. If I look from this, was it an AP what was given to me? Yes, it was an AP whose common difference was 1 was given to me. Nothing but the other way of looking at this is what? Summation series. Summation series is also nothing but an AP series. Alright, summation up to n terms is also nothing but an AP series. Okay, that's the way already you kind of look at this particular question. Right, look at this particular question. Point here is, okay, don't panic just because they use some squares, etc. in between. They just because use certain things. Don't panic because of that. Rather, just keep your ears and mind open. You will be able to deal with those questions. Right, yeah, here we go. The next one. Take a look at this particular question quickly, friends. Don't take much time. Take 30 seconds, get the basic background, and let's move on. Okay, sum up to 20 terms of this particular series. Look, what is the term here? Each bracket is a term. All right, now each bracket is a term. Probably that is something you may have to understand. All right, now this bracket is a term here. So each bracket is a term, my friends, that you need to understand it. This is the first term. All right, this is the second term. This is the third term. Therefore, there is a bracket. Now, this comes from your fifth or sixth standard. In the sixth standard itself, you learn these things. You can't question that, oh, I misunderstood like this. Then we are talking about complaining that, okay, what I learned in sixth standard, I forgot. That's what you mean to say. Right, this is the sixth, the fifth, fourth term, and so on. All right, this is the fourth term, and so on. So, how many terms are there? There are 20 terms. Look at my first term. My first term is 1. Hey, what is my second term? Is 2 square. All right, now 4, nothing but 2 square. Hey, what is my third term? It's 9, nothing but 3 square. It's a very popular series, isn't it? Sum of n odd numbers, sum of first n odd numbers is n square. See, that's a point I'm trying to make. See, all these are summation series. Basically, I'm trying to say that, hey, be comfortable with summation n, be comfortable with summation n square, be comfortable with summation n cube, be comfortable with sum of odd number, right? Sum of the first n odd numbers of the series, that is 1 plus 3 plus 5. If I write it like this, n odd number, nth odd number. If you write up to nth odd number, let nth odd number, the answer is nothing but n square. Sum of the first n odd numbers is nothing but n square, right? If you write only two numbers, it is 2 square. Till here it is going to be 3 square because you wrote 3 odd numbers. Likewise, if you write n odd numbers, it's going to be n square. Similarly, what if I write n2 plus 4 plus 6 even series up to n even numbers? Up to n even numbers, then it is going to be n into n plus 1. All right, n into n plus 1. All right, it's going to be this. In the sense, when I write 1 and 2, all right, answer is going to be 2 into 3, that is 6. Right? Yeah, similar. That's what you mean here. Okay, so summation series, I just want to be on top of that. That's my whole idea. Hey, you know all these formulas, just go there. All right, now get those particular parts right now and get it in place. In the sense, okay, so what is this? All right, now so 1 square plus 3 square plus 5 square. How do I write it? Up to n square, n odd square. Similarly, 2 square plus 4 square. I will by hearted all of them. 6 square, like this, up to n numbers. What is that? Right now, be on top of this summation series. That's my point. That's when the reflection of the mind is a lot better. Right? Okay, like this. Therefore, you know the first term, you know the second term, you know the third term. Therefore, what is the 20th term, my friends? 20th term is 20 square. Therefore, 20th term is 20 square. What is that author is asking? He's saying that sum is nothing but sum of all these fellows. Right? That's 1 square and 2 square, 3 square, up to 20 square. All of we know how to find the summation of n square numbers, right? Summation of the first and elite squares of the first and natural numbers. Well, that's 1 square, 2 square, 3 square is nothing but what? N into n plus 1, 2n plus 1 divided by 6. All right, divided by 6, that becomes the sum of the n knowledge, sum of the squares of the first n numbers. So therefore, you will say that here how many numbers here? 20. Therefore, you write 20 into 21 into 41 divided by 6. 20 into 21 into 41 divided by 6. All right, now there we go. All right, that's about this particular question. All right, that's about this particular question. Point here is what? Point about this particular question is, please be mindful and remember all these parameters. Don't ignore them because they come big time handy when you're doing certain additions, etc. Even in progressions or out of progressions, whatever be that for that matter. Right, okay, here we go to the variation now. Let's look at the variation concept. One of the important concept what we are doing under this question. Okay, find the number of common terms in the following two series. Number of common elements. See, you are already seeing one common element here, 10. 10 is one common element, like this. Now this is the first series. All right, this is the first series, this is the second series. There are two series out here. There is a first series and there is a second series. He's saying that, okay, how many common values I can observe between these two particular series? See, one you can already observe, which is nothing but 10. One you can already observe. He's saying that how many more like this, how many more like this. Okay, let me write the first series, my friend. Let me write the first series. What is the first term? 1. What is the second term? 4. What is the third term? 7. What's the fourth term? 10. Like this. Okay, can I write my 100th term there? 4. Yes, you can write your 100th term because you know your first term, you know your second term, you know your third term. Likewise, can I write up to my 100th term? Yes, you can write because these are AP series. This is an AP series whose common difference is what? 3 plus 3. So common difference is plus 3. You can write the 100th term of this particular series, right? 100th term of this particular series. There will be 99 gaps, isn't it? There will be 99 gaps. Each gap is 3. Therefore, 99 into 3 plus 1, that becomes the 100th term. We already know how to find the nth term. Nth term is equal to a plus n minus 1d. Precisely, I'm using this, no more, nothing else. So what is my first term? 1. So 100th term means what? This becomes 99. What is the common difference? Which is 3. Right? Therefore, that becomes 297 plus 1, which is 298. All right, quickly, already we can get that in our mind itself. No big deal. This is 298. Okay, that's the upper limit. Therefore, I can go up to the upper limit of 298. Okay, so that's this closure of the series. Let's write the second series. What is the second series there? What is the second series? Same, first term, there is a second term, there is a third term. Like this, how many terms I should write? Up to 80th term. Up to 80th term. What is the first term? 2, second term 6, third term 10, and so on. All right, and so on. Okay, how do I write the 80th term? Therefore, same way here. 80th term, the first term, 80th term is nothing but 79 times. So what is the common difference, friends? Plus 4. What is the common difference here? Plus 4. Therefore, 79 times. So 4 is the nth term of the second series. Nth term of the second series you're talking about. All right, therefore, that's nothing but 216, it's a 316 plus 2, that is 318. Therefore, you would say that this is going to be 318. Right, 318 here. All right, that's 318. Good. So which one I should consider therefore? So common terms, the common terms cannot exceed 298, because after 298 you may say that, hey, up to I can go up to 318. Correct, you can go up to 318. But the point is, you will not have the common terms beyond 298. At the most, 298 can be the common term between the two series here. Okay, what is the concept? Therefore, how do I find the common term? Simple, friends. Common term is a function of find the first term, the number of common terms. Understand this very carefully. Understand this very carefully. Yeah, what is the first number which is common between the two? 10 is the first number which is common between the two. Let me write another series. S is not sum, friends. S is the series. Let me write the combined series which has the common terms. The first number is 10. The first number is 10. Now the point here is, what is the common difference here? Which means, what is the second term of this combined series? Look, the first term is 10. The second term, how do I get my second term of this particular series? Instance, what will be the common difference of this particular series? The common difference, D, is nothing but LCM of the common differences of the given series. Common difference of the first series and the common difference of second series. That becomes the common difference of this combined series. Therefore, it is nothing but what? Therefore, it is nothing but LCM of 3 and 4, which is nothing but 12. Therefore, add 12, you get the next value there. It implies you add 12 to this number. All right, therefore, this becomes 22. Hey, what is the third term of this particular series? Add another 12 to this particular number. All right, add another 12 to this particular number. All right, which becomes 36. All right, which would become 34. All right, which would become 34, and so on. Therefore, the point here is, what is the nth term of this series? So that Tn is always less than or equal to 298. Don't write anything more than 298 there. All right, because 10. All right, now 10 is fine. All right, here you are talking about 10 is fine, 22 is fine, 34 is fine. Okay, my important point here is what? The common difference of the combined series is nothing but the LCM of the common differences. Is nothing but the LCM of the common differences. That word is important to me. You got to spot the first term manually. You got to spot the first term manually. Write couple of numbers to stop the write the first term. The common difference is nothing but the LCM. Therefore, nth term. Now listen to me. Therefore, how do you find nth term? You said that nth term should be less than or equal to 298. Because what if it is not 298? What if 296 is the common term? That's fine. In that case, 296 becomes the up to 296 I can go. Therefore, you write up to 298. Up to 298. Why? 298 I am fine with. I'm fine with 298. But I am not okay going beyond 298, because there will not be any term beyond 298 which would be common. See, because you may say that here it can go up to 318. But the point is, the first series is ending at 298. Therefore, I got to find that. Okay, what is nth term, my friends? Nth term is a plus n minus 1 times of d. It should be less than or equal to what? 298. I just substituted for nth term. Good. Hey, do I know the value of the first term? Yes, first term is 10. You know the value of the first term, which is 10. Hey, do I know the common difference? Yes, the common difference is 12. So n minus 1, that is what you are trying to find the value of n there. N minus 1 times of what is the common difference? 12. Should be less than or equal to what? 298. Very good. Okay, we wrote that. Therefore, let now simplify this. Therefore, n minus 1 times of 12 is less than or equal to 288. Divide this by 12, divide this by 12. Therefore you would say that n minus 1 is less than or equal to, divide by 12. Therefore 12 2 times 24, 12 4 times 48, 24. Therefore n is less than or equal to 25. Which means it can satisfy the values up to 25 terms. Now he's saying that how many terms are common. You are saying that, hey, 25 terms are common. This value of n is nothing but 25. You are saying how many terms are common between them. You are saying that 25 terms are common between them. Although the first one has 100 terms, the second one has 80 terms, the common terms are 25. Naturally, the common terms has to be smaller than the given values, right? So therefore, there are 25 terms which are common between them, which becomes my answer. Okay, learning point of this particular question is what? Learning point is whenever multiple series are given, you first find out the first term which is going to be common here. That is nothing but 10. Find the first term which is going to be common. That's the first thing. Second one, learn how to find the common difference, which is the function of LCM of the common differences. That's all. If you get these 2 points, rest is incidental. Rest is just mechanical calculation, right? Okay, all of you got this common term concept, I guess. Let's go to the next one. Another concept. Another concept. I'm sure you would have done all these things in the high school. High school, those who have done 11th standard math, it will be on top of your mind. All right, these things would be on top of your mind. Yeah, let's go there. Yeah, the sum of n terms of two APs is in the ratio this and this. That's the sum. What is given to me is sum, my friends. What is given to me is something like this. Well, no, so it said that sum up to n terms of the first series, first series divided by sum up to n terms of the second series is equal to 3n minus 13 divided by 5n plus 21. That is what is given to me. Yeah, what is sum up to n terms of the given series? How do you write it? So if I expand this should be read as n plus 2 times of, alright, n plus 2 times of, n plus 2 times of 2a1. So you'll write as 2a1 because the first series would have the a1 as the first term. Let's say that the first series has the first term as a1, right? Therefore, you will write this as 2a1. Alright, you write this as 2a1. I'm writing the numerator. I'm substituting for this 2a1 plus n minus 1 times of, what can be the common difference of the first series? D1. See, there is a series here. Technically, there is a first series here. First arithmetic series. The first series has, no, not the sum. That's a series 1. There is a first series. First series has the term as a1, and then second term is a plus d1. The next term is a1 plus 2d1, and likewise, likewise, there are terms here. Likewise, there are terms here. Similarly, there is another series s2. Similarly, there is another series s2. First term is a2. What is the second term? a2 plus d2. What is the next term? a2 plus 2 times of d2, and so on and so on and so on. Likewise, these are the terms here. So therefore, I am writing this sum up to n terms can be written like this, plus this is what? This again n by 2 times of 2a2 plus n minus 1 times of what? D2. This is how you would have written. This is how you would have written. But look here, now what author is interested in? Author is interested in 12th term, ratio of the 12th term of the series. Ratio of the 12th term of the series is what he is interested in. Is equal to, I can write this as it is. I can write this as it is. Fine. Simplify. This gets cancelled. Once this get cancelled, look guys, how the nth term will look like, my friends. How does the nth term will look like? The nth term should be of the form a plus n minus 1 times of d. This is the structure of the nth term. Keep this in mind. Keep this in mind. But now, after simplifying, what is that you have? 2a1. 2a1. Therefore, what you do? Divide both numerator and denominator by 2. Divide the numerator also by 2 and the denominator also by 2. Therefore, it looks like what? A plus n minus 1 divided by 2 times of d1. What did I do? You divided the numerator by 2. Divide the denominator also by 2. Therefore, you would have a2 let a2 plus n minus 1 by 2 times of d2. Good. Okay, now look at all right, how do you write the 12th term? Basically, how do you write the 12th term? 12th term is a plus 11d. All right, that's what you write it here, a plus 11d. Good. Okay, therefore how do you roll it? Now the 12th term is nothing but this. In the sense, what is that you are trying to say? So this comes as it is. So what is that you are trying to say is, look, I have this a for a here, I have a for a here, all right, a for a here, I have d for d here, but instead of 11, what do I have here? Instead of 11, I have this, both in the numerator and denominator, because anyway you have to find the 11th term of both the series. Therefore, what is that you are trying to say? This 11 is also nothing but this 11 is also nothing but this n minus 1 by 2. That is n minus 1 by 2 is equal to 11. That's what you are trying to say there, which means in place of n, all right, this is what you are writing, n minus 1 by 2 is equal to 11. Simplify from here, n is equal to 23. So in the sense, you are trying to say that put n is equal to 23, where here put n is equal to 23, you will get your answer. All right, you will get your answer. What did you technically do? You went on from saying that sum up to n terms of the first series, sum up to n terms of the second series. You said you translated this into, all right, 12th term of the first series, all right, t12 of the first series, t12 of the first series by t12 of the second series. That's what you wrote. All right, that's what you wrote. But what you need to put here, all right, but what you need to put here, you got to put n is equal to 23. Although here you said that 12th term is what you wanted, you will not put yet n is equal to 12. You will not put n is equal to 12 here. Instead, you will put n is equal to 23 here. In the sense, when I put here 3 times of 23, all right, minus 11 divided by 5 times of 23 plus 21, this has become the ratio of t12 of the first series by 12th term of the second series. That's a point. Now point here is, how will I understand that when they ask the 12th term, I need to substitute 23 as the value? All right, these are the steps which were involved. Trust me guys, you go and ask any 11th standard fellow, you will answer this question, all right, within 10 seconds. I'm not kidding. All right, 10 seconds, 10 seconds he will get the value of value of what he should substitute. Maybe substitute and solving another 20 or 30 seconds. Okay, how do you understand? Simple guys, now listen to me. So whenever the sum of n terms, sum of the n terms of the first series by sum of the ratio of the sum of the n terms of the first series by second series is given, let's say that this ratio is given. All right, this ratio is given. So how do you understand that what I need to put for the n there? What I need to put for the n there? Now listen carefully. Listen carefully. If all it now you want, all it now from here, this is given. What I have to find out? You have to find out. Say that okay. You have to find out kth term of the first series, kth term of the first series by kth term of the second series. All you got to do is your k. All right, your k is nothing but all right, your k. What is the value of k that you are going to substitute there? So which means here the k value was 12. All right, what is the relationship between k and n? What is the relationship between k and n? N is equal to 2 times of k plus 1. N is equal to 2 times of k plus 1. Just remember this, that's easier. If the ratio of nth terms are given, if this is given, if the ratio of nth term is given, some of the nth terms are given, then kth term has been asked. If the kth term has been asked, ratio of the kth term of both the series is asked, this is the relationship. N is nothing but 2k plus 1, which means this ratio is given to me here. All right, now this ratio is given to me here. Yeah, what is given to me? The ratio is given to me as 2n minus 13 divided by 5n plus 21. But all right, now so what is that I am asking? I want the 12th term here. Fine. Therefore, n is equal to 2 times of 12 plus 1. That is what you will understand the value of n to be. What is the value of n to be? Sorry, 2k minus 1. Right, 2k minus 1, not plus 1, take it as minus 1. All right, therefore all right, you will say that put this is equal to 23. So that is what you see, that all right, just go there here, put the value as 23, you will get the answer to this particular question. What is that I want you to remember? These boxes. I want you to remember these boxes. If this is given, and the kth term has been asked, just remember that this is what I need to substitute. Yeah, whatever I did before are nothing but the steps to arrive at that. You don't have to look at the steps to arrive at that. Rather, you understand these 3 pieces of information. These 3 pieces of information. Now go back, substitute this particular value, which would have become your answer. Just substitute. Already this would have become the answer for the given question, which would have become answer for the given question. I hope all of you got my point, what I'm trying to say. I'm sure each one of you got my point. This is the key that I wanted you to get my point there. All right, let's go to the next one. This was one of the CAT questions, beautiful question, long time back. Let's take a look at this question. Read and try to understand this question. I will come back and explain. Read, understand this question. Take a minute to understand. Yeah, here we go. There are 25 trees at equal distances of 5 meters in a line with a water well. The distance of the well from the nearest tree being 10 meters. The gardener waters all the trees separately starting from the well, and he returns to the well after watering each tree to get the water for the next tree. Yeah, if he pours exactly one pot of water to each tree, one pot, all right, one pot of water to each tree, it's clear, one pot of water to each tree. Find the total distance the gardener will cover in order to water all the trees. I will tell you what is the common mistake also that is going to happen here. Let me tell the common mistake as well. See what has happened. If I draw a line diagram, might look something like this. Say this is the well where there is water. This is well. The first tree is somewhere here. The second tree at a distance of 5 meters. There is a third tree at a distance of 5 meters. Somewhere here is the 24th tree, and there is a 25th tree. There is going to be a 25th tree. These are the 25 trees in the garden. Now look, first tree, what happens? The gardener moves this. This is 10 meters, friends. This is 5 meter. This is 5 meter. So on, right? Yeah. He moves 10 meters and returns. He has to come back. He has to come back. So because that's a cycle there, right? Come back and fill the water. Second tree, he goes till here, that's 15 meters, and he comes back. He comes back, right? Yeah. Third tree, all right, similarly the third tree, he goes up to 20 meters and comes back, like similarly the 24th tree also, he goes till here, whatever be the distance, will come back to that, and he comes back. Whereas the last tree, listen carefully, whereas for the last tree, he simply goes till here, and it is action is done, over. With this, the action is over. There is no coming back. That is the common mistake people do. You don't have to come back. The activity of watering the plants is over. At this stage, it is over. You don't have to do this. Hey, shouldn't I be coming back and putting no, keeping that pot back at the well? No, you may have to keep the pot at the tree number 25 itself, and you can go for some other activity. There is nothing wrong about that, right? So therefore you say, see, this is the common mistake people do. What the common mistake they do is, even for the 25th tree they come back, all right? Even for the 25th tree they come back. Don't come back, all right? Now therefore, what is that you are trying to say? You are trying to say that, okay, it's an arithmetic progression. It's an arithmetic progression where there is a first term, there is a first term, there is a second term, there is a third term. All right, like this there are 24 terms. These terms we need to count it two times. The total distance traveled, nothing but sum. Total distance traveled by the gardener is, so whatever the distance t1 is at, he goes to the t1 and comes back two times. Whereas the t25, when he was planting the tree 25, only one distance. All right, now so all other distances are two times except the last distance, which is going to be one time. So that's important there. Therefore, the total distance traveled is t. What is the first term, my friends? The first term is 10 meters, the second term 15 meters, the third term 20 meters, and so on, right? And so on. So therefore, the first term is 10 meters, second term is 15 meters, third term is 20 meters, the 24th term or 25th term, you can calculate one of them. 24th term is going to be 125 meters. I already taught you how to find the nth term of the series. Please find it. All right, that's 25 meters. And what about this? This is 130 meter. All right, this is 130 meter, and I can find the sum from here. So this becomes an AP. I can find the sum here. So therefore, D is equal to 2 times of, let me find the AP here, 10 plus 125 divided by 2. I'm just doing this bracket part, friends. This bracket part I'm dealing with first. I'm dealing with this. You can deal in multiple ways. I know the first term, I know the last term. Therefore, I'm adding 10 plus 125 by 2. That becomes an AP. AP into how many terms inside that bracket? 24. And what I need to add to this now? 130 I need to add. I need to add 130 to this. Okay, we can all calculate from here. Calculation should not be a concern on this. But the point here is, okay, one mistake people do is the last tree also they come back. That is one mistake they do. All right, that's a common mistake. Rest is incidental. By now you are aware how to find the nth term. That's not a worry there. By now you know how to find 24th term. You know how to find, right? Now you can find the 24th term as a plus 23 times of common difference. Common difference is 5. The first difference is 10, but the common difference is 5. Therefore you can write this particular series. All that is fine. All that is fine. The common mistake people have done in this particular problem is they take even the last distance from the last tree in the reverse order. All right, thereby they get a different answer. They get 130 more in the given answer. Right? Yeah, okay. Let's keep this in mind. So let's keep this about the arithmetic progression in total perspective. Let's go to geometric progression. Now this would have given clear background to arithmetic progression with various types of problems also that we did. I'm not saying that's the end of it. I'm saying that, okay, so whatever the best possible in the given time, let's try and explore that. So this bit should help you as we go along. The geometric progression is very, very important, friends, especially geometric progression up to infinite terms. Let's deal with that little carefully. Let's deal with that little carefully. Let's go here. Let me give a quick background here. Let me give a quick background, maybe 5 minutes background, because we are still left with about 50 minutes, 50 odd minutes. So let me give a quick background of the geometric progression. What is common here? The common ratio is common, right? Common ratio is common. Something you might say that, okay, the first term is 2. If I write the first term is equal to 2, first term is 2. The second term, if I write it as 6. And if I write my third term as 18, and if I write my fourth term as 54, you are understanding what I'm trying to do here. So I'm saying that, okay, what did I do from here till here? I multiplied by 3. What did I do from here till here? I multiplied by 3. What did I do from here till here? I multiplied by 3. That's the thing there, common ratio. There you added, here you don't add, rather you multiply by a certain number to realize that the common ratio is constant, right? Everything is multiplied by 3. So therefore, how do you generalize this technically? How do you write the general form of this particular one? You say that the first term is a, the first term is a. Second term, you say that a into r. Earlier you wrote it as d, you write this as a into r. What is this here? A r square. What is this here? A r cube. Right now, going by this particular pattern, you may say that, hey, if I write my nth term, how that should look like? A r raised to power n minus 1. Or at a r raised to power n minus 1, because when the power is 2, or when the second term, the power is 1. When you're writing the third term, the power is 2. When you're writing the fourth term, power is 3. Therefore, when you're writing the nth term, power becomes n minus 1. That's point number 1. All right, that's point number 1. So, okay, how do I find the common ratio? How do I find the common ratio? That can be T2 by T1, or that can be done by T3 by T2. That can be done as T4 by T3. You will never do it T1 by T2, my friends. All right, you can say that, hey, can I do T1 by T2? Absolutely not. Right? Absolutely not. Right now, this is what you do there. T2 by T2 by T1, T3 by T2, etc., etc. That's how you find your common ratio, right? That's how you find your common ratio. That's the second thing that you got to keep in mind. Okay, how do I find sum up to n terms of this particular ratio? Sum up to n terms of this particular GP. Sum up to n terms of this particular proofs are there. Proofs are there. Let me write it directly because of want of time. So because nobody is going to ever ask us, how do you do this? How do you prove this? That's a pretty much high school issue here. The third important point here, sum up to n terms is given by, sum up to n terms is sum up to n terms of a finite GP. It's a finite GP I'm talking about. Sum up to n terms of a finite GP is given by a r raised to power n minus 1 divided by r minus 1 divided by r minus 1, or let's say sometimes you r may common ratio may become less than 1, the common ratio may become less than 1 because T2 by T1 need not be greater than 1. See, in our case it was 3. Sometimes it can be less as well. No worries. If it is lesser, then you can also write this as a 1 minus r raised to power n divided by 1 minus r. That is also fine. So therefore, these are the 3 things I want to kind of remember about the finite GP, finite geometric progression. What is that? How do I find the nth term? Right? How do I find the nth term? Second one, how do I precisely find the common ratio? Third one, how do I find the sum up to n terms of a finite GP? Sum up to n terms of a finite GP. Now, I'll come to very important point. These all are 3 points. That's it. Only 3 points. Let's be very clear. What are our learning objectives? What is that I need to remember? All right, that's what you need to be kind of clear about, the basic parts. Okay, what do you need to store with? Sum up to infinite terms of a GP. Sum up to infinite terms of a GP. Sum up to infinite terms. Sum up to infinite terms. First, let me explain this. What do you mean by sum up to infinite terms of this particular GP? Assume that all it knows you are celebrating your anniversary or birthday, whatever. All right, I'll take a birthday. You ordered a large cake. You ordered a large cake. You said that whoever comes to visit me on that particular day, I will give half of it. I'll give half of it. Assume that it's a large cake. How many cakes you have? One full cake you have. That's it. What you have is one full cake. That's it. What you have is one full cake. Your friends are coming in this particular, whoever comes there, you will give them half of the cake. You will give them half of the cake. They can eat there or they can pack it and go, whatever it is. Your idea is pretty clear. Look, I will give half of the cake to the person who visits me. Okay, for the first person. Now listen, for the first person who visited you, first friend, or one of your first friend who visited, you gave half. You gave half of this cake, which means this blue line. All right, now this is what the first person has taken. If you ask me what you have taken, he says that half of cake, because you had one full cake. See, you can write half of cake, but see, you leave it, say that one full cake I had, one full cake I had. In other words, take it as all right now. So take it as the cake of length 1 meter. You had a cake, all right, huge cake, you would have ordered 1 meter. So you gave how much to this fellow? The cake of length, half meter length cake. You give half meter length cake. You give, that's what is the share of the first person. Good, that is gone. So now second person comes in. So second person comes in, you have the remaining half, you give, all right, half of the remaining half, all right, the green one. This is what the second person takes it. Second person takes it. Therefore, you say that, hey, what did the second person take? Quarter, 1/4 of the cake. 1/4 of the cake, because half of half, because what you are left with, you are left with half cake. So you gave 1/4 of that. All right, now you gave half of that. Therefore, the second person took how much? 1/4. That's what he will say. Okay, now the third person comes in. Let's assume that the third person comes in. He gets how much, guys? All right, now whatever was the remaining, this guy gets half of that. This guy gets half of that. Half of what? Half of 1/4, which becomes how much? 1/8. Half of 1/4. Half of, I hope everybody is getting this concept here, right? First person gets half, the remaining was half. The second person get half of half. Therefore, that becomes 1/2. See, it's half was remaining. Half of half is what he gets. So therefore 1/4 is gone. Therefore the remaining is how much? 1/4. What is the third person getting? Half of 1/4. All right, half of 1/4 is getting half of 1/4. Half of 1/4, which is nothing but 1/8, and so on. Hey, is there any end to this? There is no end, because always some portion will be left. Because to nobody you are saying that take all the remaining. To no one you are saying that take all the remaining. There is always half of left, which means if the friends keep coming, keep coming. That's what you mean by sum up to infinite terms of this particular GP, because it never ends. It never ends. It may become microscopic in nature. It can become microscopic in nature, but then there is always that half of that atom which is left. Remember, there is not going to an end. Therefore, you are saying that sum up to infinite terms of this particular AP. Hey, what is sum therefore? Hey, what was your total cake? If I ask you what is the total cake you had, sum therefore should be half that's given to the first friend. Second friend took this, third friend took this, and so on and on and on and on. All infinite friends. You have many friends. I'm not saying infinite. You have many friends. See, all the friends took it. It should be equal to what? One full cake, right? That should be equal to one full cake. So therefore, how do I get friends? Sum up to infinite terms. Sum up to infinite terms is first of all defined whenever the common ratio lies between 1 and -1. That's the first condition. First condition, you can't say that you have one cake to everybody, you will start giving two cakes. Common ratio is more than one. No, you just had one cake. How you can give all it now? Start giving 1.5 cake to the person. No, therefore the common ratio should be a proper fraction. At the same time, R should not be 0. We are all aware. Common ratio should not be 0. Of course, we know that. Common ratio should not be 0, because 0 also lies between 1 and -1. Except that common ratio can be anything. Common ratio has to be a proper fraction. That is the first point. Common ratio should be a proper fraction. Second one, if it is ensured that the common ratio is a proper fraction, sum up to infinite terms is given by a divided by 1 minus r. A divided by 1 minus r. Okay, let's come here. What is the first term, my friends? This is a. What is the common ratio? Common ratio is T2 by T1. What is T2 by T1? 1/4. Where is T2? Here, 1/4. Here, what is T1? 1/2. 1/4 divided by 1/2. All right, now do the division. 1/4 divided by 1/2 is nothing but 1/2. All right, which is nothing but 1/2 there. Okay, that's a common ratio. Therefore, common ratio is 1/2. Substitute it here. All right, now therefore you would say that, all right, sum up to infinite terms on this cake problem is nothing but, what is the first term? 1/2. What is the common ratio? That's also 1/2. All right, what is the result here? 1, which means how many cakes you had in the beginning? You had one cake in the beginning. You had one cake in the beginning. That's what you do there. Okay, what are my common learnings here? Sum up to infinite terms, two learnings. Sum up to infinite terms is possible only when the common ratio is a proper fraction. That is the check. All right, is it a proper fraction or not? Otherwise, don't try to do this concept. So common ratio has to be a proper fraction. Then sum up to infinite terms is given by infinite terms. Right now, sum up to infinite terms, answer is finite. Sum up to infinite terms, the answer is finite. That's measurable. Right? Sum up to infinite terms is given by a divided by 1 minus r. Let's keep this in mind. That's all the basics about this. About 2 points about sum up to infinite terms. All right, and about 3 points about the three points about the finite terms. Let's keep this in mind. Let's go to the application, friends. All right, let's go to some of the simple applications here. All right, let's take a look at this question. Let's take a look at this question. Get the answer to yourself. It's a simple one. Get the answer to yourself, all of you. Get the answer to yourself on this question. I hope everybody is learning. Get the answer. Yeah, good. All right, now pretty simple one. Pretty simple one. You don't need my interference into this. You don't need that. Nevertheless, let me do this. The fourth term is given. What is fourth term? The fourth term of a geometric progression. How do I write? The fourth term is nothing but AR cube. What is AR cube, friends? AR cube already. AR cube is 1 by 3. The fourth term is 1 by 3. All right. Similarly, the ninth term is given. What is ninth term? Ninth term is nothing but AR raised to power 8. All right, which is nothing but 81. 81. So his question is what? All right, respectively, find the first term. His question is, why don't you find the value of a? All right, why don't you find the value of a? Good. All right, now so I have two propositions. Divide. All right, divide the first. Let's say that okay, this is the second equation, this is the first equation. I'm saying that divide the second equation by the first equation. So therefore you will say that AR raised to power 8 divided by AR cube is equal to 81 divided by 1 by 3. I divided the second equation by the first equation. Therefore, r raised to power 5 will become 81 into 3. Technically, 81 into 3 is nothing but 3 raised to power 5. Therefore, r is equal to 3. Therefore, r is equal to 3. Good. Okay, but point is, I don't want r, we want a. So let's go to the first equation from there. Go to the first equation and substitute for the value of r. A r raised to power 3 is equal to 1 by 3. Therefore, a r raised to power 3 is what, my friends? 3 cube is equal to 1 by 3. Therefore, a is also nothing but 1 divided by 81. All right, that is the required answer. Fine. The answer is pretty simple, straightforward. Just a small drill to write how to write the fourth term, small drill to write the ninth term. And technically here you don't add them. My point here is you will always divide them here, because anyway it's all ratios, right? Ratios is more to do with the divisions, etc. Therefore always you think of such algorithm. There you always think of such algorithm. I'm sure all of you are pretty comfortable about this. This should not be C. Similarly, whatever we discussed in progression, whatever we discussed in arithmetic progression is true here as well. See, how did I say that? How to find the arithmetic mean there, friends? First and the last divided by 2. Here what you do here, if you say that the first term is there, second term, third term, fourth term, fifth term, etc. are in GP. Now the middlemost term is also called as geometric mean. Also geometric mean, what if I know the first and the last term? Find the square root of the first and the last term, like this. That also gives me the geometric mean, which is also same as the second term and the second last term. That is also fine. All these are geometric mean. Or this is also nothing but T3, because there is only one term. Alright, there is only one term. No need of a square root here. No need for a square root here. Also geometric mean can also be found as a, I will take all 5 of them, no problem. Then you do the fifth root of T1 into T2 into like this up to T5. That is fine. If you want to multiply all 5 of them and find it, this is how you will find the geometric mean. So very similar to whatever I did in arithmetic progression is same as geometric progression. There we talked about the addition and subtraction. Here we are talking about the multiplication and division. Alright, that's important there. Alright, now that's important there. Great. Alright, let's go further. Let's go further here. Yeah, we are getting into the infinite part because that's more important for us, and we'll do the applications built on that infinite part, my friends. Let's do this. In an infinite GP, every term is 7 times the sum of all the terms that follow it. First, let's understand that statement itself. Well, so what is given to me is something like this. Say that if I have the terms T1, T2, T3, T4, T5, and so on, and so on, and so on. Many terms are there, up to infinite terms. There are infinite terms. There are many, many terms because it's an infinite GP. It's given to me. It's an infinite GP. Naturally, what is an infinite GP? The common ratio would be a proper fraction. Common ratio will lie between -1 and 1. That is given. That's what it means. Alright, that's a meaning of the word saying that it's an infinite GP. Common ratio lies between -1 and 1. Okay. So now what did he say here? Alright, he said that every term, okay, every term, let's define on this. Every term, that is T1 is equal to, every term is nothing but 7 times the sum of all the terms that follow it, which means T1 is nothing but 7 times of T2 plus T3 plus T4, like this. All right, now like this up to infinite terms. Every other term which follows it, every other term which follows it. You may say that, hey, can I start from T2 also like this? Of course, yes. T2 can be written as 3, all right, now 7 times of T2 can be written as 7 times of T3 plus T4 plus T5 and so on till infinite terms. That is nothing but the definition of T2. That is the meaning of this underlined word, the sum of all the terms that follows it. Every term is nothing but sum of all the terms that follows it. But now author is saying that, okay, T1 plus T2 is 9. Or let's find the values of A and R. Find the values of A and R. I can do from anywhere here. Let us start from here for that matter. Let us start from here. How do I start from here? What is the value of T1, friends? Technically, what do you say the value of T1? T1 is nothing but A. T2 is nothing but what? AR. T3 is nothing but what? AR square, and so on. That's what you do there. Fine, fair enough. Therefore, let us write it. What is the value of T1? A. 7 times of 7 times of what is the value of T2? AR. Now here what I write, AR square and AR cube and so on up to infinite terms, up to infinite terms. Observe this. What is this here? Infinite terms of a GP. Sum up to infinite terms of a GP. What did we learn? All right, we learned that, all right, that's nothing but A divided by 1 minus A. What is A technically? The first term. A is nothing but first term. But here, what is the first term? First term is AR. First term is AR. What is the common ratio between the terms? That is still R. Common ratio is still R. Therefore, A is equal to 7 times of, I'm applying sum up to infinite terms of the GP, my friends. AR, don't get confused. AR is the first term. AR is the first term of that bracket. All right, now here I said that the first term we take it as A, but here it has become AR. Don't get confused between them. AR and then 1 minus R. AR and 1 minus R. Why? The common ratio is still R there. Common ratio is still R there. Simplify. A and A gets cancelled. A and A get cancelled. Therefore, 1 minus R is equal to 7R. Alright, that's nothing but 1 is equal to 8 times of R. In other words, R is equal to 1 by 8. In other words, R is equal to 1 by 8. That is one of the values. You may wonder that, hey, can I get that value of R from here also? Can I get the value of R from here also? Of course, yes, you can get it from there as well. So let me do it, all right, as a matter of practice. Let me do it. Okay. So what is T2, my friends? T2 is nothing but AR here. What is T2? AR. Good. AR is equal to 7 times of, that is T2, right? Okay. So T3, all right, now here T3 is what? AR square. Okay. AR square plus AR cube plus AR raised to power 4. It goes on up to infinite terms of this GP. Now focus on this bracket. Let's focus on this bracket because this is sum up to infinite terms of the GP. What is the first term here? AR square. Okay, therefore first term is AR square. 1 minus, what is the common ratio? Common ratio is still R. AR square and AR cube. What is the difference? R only. All right, what is the ratio there? R only. Okay, that is 7 times of, right? 7 times of AR is equal to, now here A gets cancelled. You cancel 1 R from here. Therefore, again you write this as 1 minus R is equal to 7R. From here you will get the value of R is equal to 1 by 8. Same answer you get. It does not matter from where you calculate. It does not matter from where you calculate. My point is just understand what is author is trying to communicate. Once you understand what author is trying to communicate, from where you do, it really does not matter. Okay, R you got. Already with the value of R you got here. The value of R you got here. Now from here, alright, now the second point here, you would say that, okay, therefore what is A here? Alright, how do I get? Now use this information. Therefore use this information. T1 plus T2 is equal to 9. Let's use it. T1 plus T2 is equal to 9. What is T1? T1 is A. Okay, what is T2? T2 is AR is equal to 9. Do I know the value of R from here? Yes, I know. Therefore 1 plus A times of 1 by 8 is equal to 9. Well, it is equal to 9. That is 9A by 8 is also equal to 9. Alright, 9A by 8 is also equal to 9. Therefore, alright, now you would say that A is equal to 8. Alright, therefore A is equal to 8. Two values you got. The value of A is nothing but 8. The value of R is nothing but 1 by 8. Alright, the value of R is nothing but 1 by 8. Okay, that's what you got there. Okay, my point is very simple. I'm just introducing you to infinite GP by giving some statement as to what is an infinite GP. How do I get the first term of the infinite GP? I just oriented you. I kind of oriented you into this. I oriented you into this. Okay, let's go to the applications now. Let's take a look at the applications. One of the applications, or it can look something like this. Take a look at this question, read it. Let's look at the applications of infinite GP, which is very, very important. Next 20 minutes is very important, friends. Sum up to infinite GP. Take a look at this. Okay, a little bit of background is required here, right? Okay, sum of solid now. The first, let's take an equilateral triangle. Let us take one equilateral triangle. If there is an equilateral triangle of side 6 units, say there is an equilateral triangle of side 6 units. Let A, say side B, A, A units. A is the side. How do I get the area here? Area is nothing but root 3 by 4 times of A square. Very basics of geometry. Equilateral triangle and right angle triangle are pretty famous. If A is the side of an equilateral triangle, each angle is 60 degrees. Well, it does not matter. All it know what matters to me. Area is nothing but root 3 by 4 times of A square. What is the side here? The side of each side of equilateral triangle is 6 units. Therefore, what is the area? Area is equal to root 3 by 4 times of 6 square. Area is equal to root 3 by 4 times of 6 square. We can simplify this. That's not a worry there. Alright, that is not a worry there. That becomes 9 root 3. Therefore, you are saying that area of the outermost triangle is going to be 9 root 3. Right, area of outermost triangle is going to be 9 root 3. Fine, let's keep that. So now the point here is, okay, if you take one equilateral triangle, just one equilateral triangle, so Dalit from the figure, now listen to me very carefully, friends. The other triangles, just understand this once very carefully, you will get the idea here. Another triangle is formed by joining the midpoints of the sides of the triangle. Joining the midpoints, I took the midpoint of this side, say ABC is the triangle. Let ABC is the triangle. Join the midpoint. Join the midpoint of AC. Join the midpoint of AB. Now listen, when I do this, when I do this, the areas, if the area of this triangle is X, area of this is also X, area of this is also X, area of this is also X. But the, what is all it now? He's saying that what is this therefore? All it now, area of this has nothing but area of all it now. So let's call it as D. We call it as DEF. Let's call this as DEF. Just like ABCDEF. My point here is area of the triangle DEF is nothing but 1/4 of area of triangle ABC. 1/4 of area of triangle ABC. Alright, now that is what it would become, because that is 1x out of the 4x. 4x is the area of the triangle ABC, but area of DF becomes 1 by 4. Now similarly, what if I take the midpoints of this? What if I take the midpoint of these particular sides? I take the midpoint of these particular sides and form another triangle called PQR, a triangle PQR. Then you will say that, man, the area of the triangle PQR would now become 1/4 of area of the triangle DEF, 1/4 of the triangle area of DEF. What is that you are trying to communicate? Therefore, if you have these triangles, ABC is one triangle, has some area. Then you have the triangle DEF. All right, now triangle DEF is the next triangle that is formed by joining the midpoints. The next triangle is PQR, which is joined by forming the next areas by joining the midpoints of DEF. What is that you are trying to communicate? If this is X, this is going to be X by 4, and this is going to be 1 by 4th times of X by 4. That's what you are trying to say. Well, that's what you are trying to say. That is nothing. Therefore, what is the common ratio, my friends? Common ratio is 1 by 4. Common ratio is 1 by 4 from here till here. From here till here, you multiply by 1 by 4, you get it. From here till here, you multiply by 1 by 4, you get it. Look at this. It's a beautiful question. Sum up to infinite terms of the GP, because you can always join the midpoints and keep forming the triangles. Therefore, what is this you are trying to say here? You are trying to say that, okay, I am talking about the infinite GP only. I am talking about the infinite GP. Fine, let me create space to write the answer therefore. So we understood now what is happening in this question. Right, we understood it's an infinite GP. It's an infinite GP in which the first term is X, the second term is X by 4, The third term is x divided by 4. Let x divided by 4 square, that is x by 16. Therefore, what is that you are trying to say? The first term is x, the common ratio is 1 by 4. Therefore, sum up to infinite terms is nothing but first term is x divided by 1 minus 1 by 4. Common ratio is 1 by 4. Therefore, you would say that, hey, this is nothing but x divided by 3 by 4. In other words, 4 by 3 times of x. Good. What was the value of x? X was nothing but this here. This was the x. X is nothing but the area of the first triangle. X is nothing but the area of the first triangle there, which is nothing but this. Come back, substitute. Therefore, you say that answer is 4 by 3 times of 9 root 3. Alright, 4 by 3 times of 9 root 3, which is nothing but 12 root 3. A sum of the areas of all the triangles would finally turn out to be just 12 root 3 units. Alright, given that the side is nothing but 6 units, sum of the areas of all the triangles would turn out to be 12 root 3 units. That's the beauty of this particular question. Right? That's the beauty of this particular question. Let's move on in the sense, okay, you find the sum up to infinite terms in various instances. Right? Various instances. This geometry was one of those instances, right? One of those instances. Let's go to the next one. Very popular question. I'm doing some of the very popular questions built on this concept. Let's take a look here. Well, guys, another 25-30 minutes. Push yourself. Don't relax your mind. I know sometimes it can be monotonous, but yet I'm hoping that everyone is enjoying this. They're all learning something. Read this question, understand, I'll explain. Okay, what author is trying to say is assume a tower. Let's assume a tower. Let's assume a tower here. Says the red one is a floor. Right now there's a floor. Assume a tower. Right? Assume a tower. The ball has been dropped from the top of this particular tower. Alright, ball has been dropped from here. Ball has been dropped from the top of this particular tower. Let's assume the first time the ball travels this particular distance, is saying that, okay, whatever the distance it travels, what is this, friends? 120 meters. Alright, that's the first time. Alright, the ball travels this particular distance, that is 120 meters. The first is 120 meters. Then what happens subsequently? Subsequently, it happens that ball rebounds to 4/5, 80% of the height. 80% of the height, but the point is it has to come back the same distance. It will come back, it will not stay there. All right, the green line is 2 times. Say, what is the 80% of 120? All right, 80% of 120, 96 meters. It rebounds to 96 meters and comes back by the same 96 meters. That is 4/5, 80%. All right, 4/5 of the height. We can calculate 4/5. That is not a worry. That's not a worry. We can calculate that. Then what happens? Again, it goes 4/5 of this number for 80%, and again it comes back. Again it comes back. Then what happens? Again it goes to 4/5 of that particular height, and again it comes back. Now this happens how many times? It goes on and on and on and on infinity, because 4/5 always exists. 4/5 always exists. All right, even it becomes minuscule, which means the vibration of the ball does not stop. All right, it goes on and on and on, sum up to infinite terms. See, again, just like we did in one of the problems, what is critical here? This blue line is only one time. After that, every other line is 2 times. This is 2 times, this is 2 times, this is 2 times. Therefore, it is sum up to infinite terms of the GP, no doubt about it. It is sum up to infinite terms of the GP, or it's sum up to infinite term of the GP, in which the first term is 1 time. The first term is 1 time. However, the next term onwards, it is going to be 2 times. 2 times of the second term, 2 times of the third term, 2 times of the fourth term, and 2 times of the infinite term. All other terms 2 times. That's important there. Only the first term is 1 time. That is unique. Alright, because it is dropped. It is not thrown from the bottom. It is dropped from the height. Alright, which has fallen from a height. Alright, therefore, first term is 1 time. Every other term is 2 times. And of course, it's a GP. We all know that, okay, it is nothing but the GP, infinite terms. Very good, friends. Therefore, sum up to infinite terms, sum up to already infinite of this particular GP. Alright, now infinite technically comes here. This underlined portion is actually the sum up to infinite. Good. This is a static number. I add 120 plus 2 times of, yeah, what is the first term here? 96. All right, 96, because I already explained that 96 here. The first term is nothing but 96. Yeah, what is the next term? Next term is going to be 4/5 of 96. That is it. What is the next term here? It is a fraction. 4/5 of 96. That's the next term. Yeah, what is the next term? 4 by 5 whole square times of 96. All right, 96, because the common ratio is 4 by 5. It goes on and on and on. Okay, fine. So therefore you will write sum up to infinite terms as 120 plus 2 times of a. What is the a here, friends? First term 96. Yeah, what is the common ratio? 1 minus 4 by 5. That's a common ratio, a divided by, because where is the sum up to infinite gp here? I'm applying here. So on this, I'll let know what is the first term here. This is the first term. Yeah, what is the common ratio here? 4 by 5. Therefore I know my first term, I know my common ratio, and this is what I'm up to calculate here. This is nothing but 120 plus 2 times of 96 divided by 1 by 5. All right, 96 divided by 1 by 5. We can simplify this. That should not be a challenge. Therefore plus 2, all right, into 96 into 5. Right, 96 into 5. Technically it becomes this. All right, therefore it becomes 960 plus 120. All right, now which becomes 1080. All right, which becomes 1080. All right, now that is the total distance. Basically that is the distance. You may reread this as the distance traveled. Total distance traveled by the ball. You can rather call it as a total distance traveled by the ball. Here, where is the sum up to infinity constant is coming? Now here where the sum up to infinity concept is coming in between all of this. Right, now thereby, all right, now this becomes your answer. This becomes your answer. Okay, now because it's one of the very popular questions here, it has a short form as well. Remember this, guys. If the ball rebounds, first of all, the ball is fallen from a height. Ball is fallen from a height, and that height is given. All right, that height is given. Assume that this height in this case is 120 meters. That height fallen from a particular height. The ball is dropped from a particular height and then rebound. All right, now rebounding. Let's assume that the rebounding. All right, the rebounding happens in the ratio A divided by B. In this case, what is A by B? 4 by 5. All right, naturally A would be less than B. There is no doubt about it, because rebounding cannot be beyond. All right, now beyond, all right, from where it has dropped. All right, now then the question, all right, becomes infinite. It goes up and up and up, and it escapes in the space. All right, that cannot happen. Rebounding is 4 by 5. Rebounding is happening, all right, now at the 4 by 5 part. Okay, good. So that is what is happening. Then the distance traveled, total distance traveled by the ball can be written as height times of b plus a divided by b minus a. It can also be written as b plus a divided by b minus a. All right, now what is b here? All right, now here the b is here in the denominator 5. What is a here? 4 here. So therefore you can also write this as height was known to me. That is, therefore all it can be written as, all right, therefore the distance traveled can be written as 120 times of b plus a, that is 5 plus 4 divided by 5 minus 4. All right, becomes the same answer, 1080. Even that becomes the same answer, which is 1080. I hope all of you got this. This is one of the very popular questions, therefore the short form exists. I would rather suggest that, okay, we all remember this particular short form. We all remember this particular short form, right? If it is fallen from a height called h and it rebounds to a proposition, rebound by a proposition called a by b, or a by b fraction form, then we can write the total distance traveled by ball will be of the form h times of b plus a divided by b minus a. We can remember, we can answer such questions a little faster and better. Okay, let's go further. Let's go further. Let's go further. All right, let's take a look at this particular series. Let's take a look at this particular series. Okay, are you getting this? Okay, this is not a GP here. All right, this is not a GP here. It is called, or it is some other. All right, it's not a GP here. So GP here, don't go by this title here. Don't go by the title that has been mentioned. I'm not talking about a GP. It's another type of question that I'm talking about, right? Another type of question I'm talking about. Sometimes what happens is the difference will be constant in the third line. In the sense, now look at this series, friends. For the look at the terms of this series, I want you to notice this. I want you to notice this. I'll give a generic form which I want you to remember. The proofs are pretty simple, 2, 3, T4 like this. It goes on, let's say. I'll let now whatever be the number of terms, let's not worry about it. The first term, all right, now here given to me as 3, second term 5, the third term 9, the next term 15, and so on. Now listen. So take the difference here. First difference here. All right, now keep writing the difference. I'm not talking GP at all. Don't bother. Take the difference here. 2. Take the difference here. 4. Take the difference here. 6, and so on. Okay, and take the difference in the next line, my friends. Already, if you want to write one more term, just for a clarification, you write it. So you can write T5, which is 23 given, and it is going on 30 terms I want here. Okay, and the difference here, difference between these two terms, which is 8. Okay, now here you wrote the differences. First difference is done. That's the first difference. Now therefore let me write another difference here. The difference is 2. I'll write another right difference, 2, 2 and 4. The common difference is 2. Here the difference is 2. Here the difference is 2 plus 2 plus 2 plus 2. Just remember like this. Whenever the difference is constant in the third line. See, generally in an AP what used to happen, let me give an AP example here. T1, T2, T3, T4, T5. Had I just written it as a 2 here, 5 here, 8 here, 11 here, and 14 here, the difference is common in the first line itself. 3 is the difference. Of course, I'm doing T2 minus T1. If it's a decreasing AP, naturally I will write the difference as a common difference negative there, because it's an increasing series, therefore common difference is positive. All right, here it is 3. All right, this difference is also 3. So this is also 3 here, and this is also 3 here. Everything is 3 here. Everything is 3 here. The difference is constant right here. The difference is constant right here. Right here, the difference is constant. But here, the difference was not constant. The difference is constant in the next line. Difference is constant in the next line. Now remember, if the difference is constant in the first line, the nth term is given by, all right, nth term is given by an plus b. Nth term will be of the form an plus b. Don't get confused, it looks like that. Now finally you wrote the same thing as nth term is equal to a plus n minus 1 times of common difference. We learned all this. This becomes an AP. Alright, this becomes an AP. This can be finally written as AP. Or in other words, the general form is this. General form is nth term will be of the is a linear function. Nth term is a linear function. Okay, why I'm talking about this? This is important from CAT perspective. The difference in the second line is constant is very common in the CAT perspective. Okay, here you write that nth term will be of the form. Here the nth term will be of the form an square plus bn plus c. An square plus bn plus c. That's how the nth term looks. In the sense, the nth term is a quadratic function. If the difference is constant in the second line stage difference is constant, nth term will be constant. Nth term is a quadratic function. What if the difference is constant in the third line? Third time the difference becomes constant. The nth term becomes a cubic function. Now don't go till there. For us from the CAT perspective, this is important. If I can get this point, it is important. Now listen to me. How do I get the values quickly there? Okay, 1 by substitution, you can get 3 terms and you can write it. Alright, 1 of course by substitution. What do you mean by first substitution? Put already n is equal to 1. If I put n is equal to 1 in the Tn, alright, no, because I know the Tn here, guys. So I know the Tn. What is Tn? Tn is equal to an square plus bn plus c. Alright, plus c. Alright, now put now n is equal to 1. If I put n is equal to 1, I'll get the value of T1. Value of T1 means what, guys? N is 1 there. A plus B plus C, that is equal to what? What is the value of T1 here? T1 is nothing but 3. I can write it. First equation I get. Put n is equal to 2. I'll get the second one. T2. Alright, therefore I get the T2 here. T2 is nothing but what? Alright, now put n is equal to 2 there. Alright, you get it as 4A plus 2B plus c, that is equal to what? Now that is equal to 5. Where it is here, it is given. That's equal to 5. That's given. Okay, so put n is equal to 3. You write it as T3. Now T3 is equal to n is 3. Just substitute in this. I'm substituting in this. Okay, put wherever n is there, put 3 there. It becomes 9A plus 3B plus c. That is equal to what? 9. Fine. So that's what I technically do. From here, what do I do? 3 equations. I take these 3 equations. 3 variables. So 3 equations, 3 variables. I get the value of A from here. I will get the value of, after solving, I get value of B here. I get the value of C here. Then I do what? Then come back and substitute here. You know the value of A, you know the value of B, you know the value of C. Then finally he wants what? 30th term. I can find the 30th term. 30th term I can put n is equal to 30. I know value of A now. I know the value of n also. What is value of n? 30. I can get the answer for that, right? I can get the answer for that. That is one method. Now second, I directly want you to remember, because some things which are very, very important important for us from the CAT perspective, we got to have a ready format there. All right, for them we need to keep a ready-made format because they're very frequent. Wherever things are very, very frequent, we create a structure. Now listen, how to get them is something like this, friends. Okay, so now here you have to write this as, see this term, what I have to focus, you just have to focus on three things. One, the second one, and this third one. Second one and this third one. Now this is always of the form 2a. This is always of the form 2a, which means what? You will immediately get the value of a from there. That's always of the form 2a. Okay, now what about this? This is always of the form 3a plus b. This is always of the form 3a plus b. All right, now 3a plus b. Okay, you get the value of b from here. This is always of the form a plus b plus c. I want you to remember this. Write this structure, focus on these three elements, focus on these three elements and equate it to the 2a one. First I will solve it here. I will solve this part first. First I will solve this particular part. 2a is equal to 2. Therefore what is a is equal to? A is equal to 1. Oh, immediately I got the value of a there. 2a is equal to 2. Therefore a is equal to 1. From there what I do? I come here. I already know the value of a. Therefore I get the value of b from here. Therefore you say that b is equal to minus 1. Therefore b is equal to minus 1. Why? 3a plus b is equal to 2. A value is 1 there. Therefore what is b here? B is equal to minus 1. You got that. Then I will go here. I know value of a and I know value of b by now. Therefore I can get the value of c. What is the value of c here, friends? Therefore 3. So immediately I got the values of a, b, c without solving too many equations. But you got to remember these three circles. You got to remember this a plus b plus c. You got to remember this. This is 3a. You got to remember this 3a. This is 3a plus b. Right now one of them is 3a plus b. The other one is 2a. You got to remember these three pieces of information so that you get the values of a, b, c faster. Therefore you can write your nth term here, my friends. What is nth term? All right, now so here let me go here. Nth term is nothing but an square plus bn plus c. Already you had bn plus c. You know the value of a now. Already now substitute. Nth term is nothing but 1n square because the value of n is 1. So what is the value of b? Minus 1. Therefore minus n. Hey, what is the value of c? 3. What is the value of c? 3. Good. But what author wanted? He wanted the 30th term. Good. 30th term is equal to 30 square. Alright, 30th term is nothing but 30 square minus 30 plus 3. That's it. In a sense, okay, this is the simple series. You can do by trial and error also. That's not my worry. My worry is knowing this concept of nth term will be of this particular form, and knowing the concept of, okay, I should be knowing this. All right, now should write it as 2a. I should write this as 3a plus b. I should write this as a plus b plus c. Knowing that concept is important. Okay, should I be remembering this for the cubic also? Not required. All right, not required. This quadratic is more than enough from the exam perspective. Just remember this because this is what you get more often than not. More often than not. If that comes, I already taught you how to write the equations and solve. We will spend that time and do that. Worst case scenario if that comes. But let's not worry about the worst case scenarios. Let's kind of worry about what is the best case scenario, the concepts I need to build, right? That's a whole point there. I guess all of you got the point with this question. I guess all of you got the point with this question. So I'm giving you also some of the things that you got to remember. All right. If you remember, the agility, the speed would automatically come. The speed would come. All right. Yeah. Let's go to the next one. Very, very popular one, friends. This is a very, very popular type. Very, very popular type. Think about it for 30 seconds. Just think about it. I'm not asking you to solve another 15 minutes of lecture, 15, 20 minutes of lecture. Think about it. Think about this. Okay, the golden standard on this particular question. Let's do this first. Let me take a golden standard. The question knowledge. Now this is a gold standard. This is a gold standard on this question. S is equal to 1 plus 1 1. All right, plus 1 1 1. That's a gold standard, guys. So this method is the gold standard. What I'm talking here, right? And then you have 1 1 1 1. If I write it like this becomes a very gold standard kind of question, right? 1 1 1 1. So let me take it all right now. So up to 10 terms of this particular series. Let me write up to 10 terms. Let me write up to 10 terms. This is the first term. This is the second term. This is the third term. Let's say this is the fourth term. Like this, there is a 10th term. Okay, we know what is the 10th term there. That's not a worry. But let's understand what do I do this. All right, now listen. Whenever you have something like this, first you will always make them nines. That's a golden thing. All right, no. So what do you mean here? Multiply and divide by 9. S is equal to 1 by 9 times of. Write this as 9. Write this as 99. Write this as 999. Or let write this as 4 nines. You may wonder why I'm writing like this. We'll come to this. Likewise, you can write up to the 10 terms, whatever is the 10th term, we can write it. Okay, what did I do? I multiplied and divided by 9. I multiplied by 9. I also divided by 9. My result is same. Okay, I'm not solving this question. I'll come to this question later. First, let's understand the gold standard on this. Very, very important concept. All right, gold standard on this. Therefore, you write this S is equal to, it's a method. I'm teaching the method in algebra because algebra also has methods involved in that, right? Now, therefore, I need to understand that 9. Now, look at this first term, my friends. Look at this 9 here. 9 can be written as 10 power 1 minus 1. That's the thing. This is a method. This is a method. All right. Now 10 power 1 minus 1. Very good. So what about the second term here? The second term is nothing but 10 power 2 minus 1. Oh, now you are getting a pattern here, right? You are getting a pattern. Hey, what about the third term here? 999. This is nothing but 10 power 3 minus 1. Beautiful. All right. You are getting a pattern. Now you understood what is happening. Therefore, what is the 10th term on this, my friends? There is a 10th term here. The 10th term is 10 raised to power 10 minus 1 because the first term is 10 raised to power 1 minus 1. Second term is 10 raised to power 2 minus 1. Like this, when you're writing the 10th term, it looks like this. That's a beauty here. So therefore, S is equal to 1 by 9 times of 1 by 9 times of 10 power 1 plus 10 power 2 10 power 3. All right, now all powers you write there 10 power 10 because you are going up to 10 terms plus minus 1 minus 1 minus 1. You are writing minus 1 how many times? 10 times. Or 10 times. Why? Because there is 1 minus 1 here, there is second minus 1 here, third minus 1 here, and there is a 10th minus 1 here. So I'm not changing this 1 by 9 at all. All right, I'm putting this 1 by 9 as it is there. Right now, this is what you have. You see, this is where the GP is coming. This is where the GP is coming. All right, this is where the GP is coming. There is a first term A here. And there is a common ratio R is equal to 10 here. Common ratio is 10. Therefore, you write that sum is equal to 1 by 9 as it is. All right, 1 by 9 as it is. All right, now so here, all right, now what is the sum up to n terms of the GP, friends? Sum up to n terms of the GP is a r raised to power n minus 1 divided by r minus 1, not infinite. It is sum up to n terms of the GP. Therefore, you say that a is nothing but 10. How many terms you are writing? 10 terms you are writing. Therefore, 10 raised to power 10 minus 1 divided by 10 minus 1. All right, divided by 10 minus 1. All right, minus. All right, no, because minus 1 times of 10 is what? Minus 10. All right, that's your answer. That's your answer. We can simplify this. That's a later issue. We can simplify this. My point is not about the simplification. My point is about understanding and remembering this gold standard. All right, this gold standard should be right in your mind. What do you mean by gold standard? The method. Right now, so we should first bring it back to a position of, all right, get the ones here first. Get the ones, because from ones you can get the nines. From ones you can get the nines. Once you get the nines, you will see a GP. You'll see a GP. These kind of questions always become a GP somewhere inside. That is the structure I want to carry. I want you to carry in your mind. All right, that's a kind of a structure I want you to carry in your mind. Okay, let's take a look at this example. Therefore, let's take a look at this particular example. Therefore, so there is a sum here. Therefore, sum 5 is there. 5, 5, 5, 5, 5 is there. First, I should do what? Hey, make them once. Yeah, make them once. Okay, how do you make it once, man? How do you make this once? Well, you make this once by taking the 5 common. Take the 5 common first. You therefore you write it as 1 plus double 1 plus triple 1 plus 4 ones and so on and so on and so on up to 25 terms. Okay, there is T25. Fine, no problem. Let's write it. Hey, but then next what I want is 9. All right, now 1 should become 9. 1 should get converted to 9. Therefore, S 5 divided by 9, multiply and divide by 9. So now it has become 9. It has become 99. It has become 999 and so on up to 25 terms. Up to 25 terms of this particular series. Good. So that's what the point is. The point here is convert them to the gold standard of ones, and then remember the method. You know how to tackle this particular approach. Therefore, S is equal to now 5 by 9 times of, right, the first term 10 power 1 minus 1, second term 10 power 2 minus 1. That's what you are writing. Right, the first term 9 can be written like this. 99 is written like this. Likewise, you wrote this as 10 raised to power 25 minus 1. All right, 10 raised to power 25 minus 1. All right, that's how you wrote there. All right, that's how you wrote there. Therefore, sum is nothing, but we know how to consolidate from there. So all these terms are in GP, right, my friends? This is in GP. This is the 10 power 1, 10 power 2, 10 power 3 are in GP. All right, therefore, first term is A. At how many terms? 25 terms. 10 raised to power 25 minus 1 divided by common ratio minus 1. All right, minus 25. minus 25. Why minus 25? There is 1 minus 1, the another minus 1. 25 times minus 1 is coming. Minus 25, which becomes your answer. Technically, this is your answer. You would have simplified in one or the other way. That we will see, and we will resolve in which way the person has simplified. In that way, alright, we can resolve this. Alright, in that way, we can resolve this. Alright, this one type of question. Alright, this one type of question which is pretty much a standard, which is pretty much a standard there, right? Very much as a standard. Okay, here we go. Now, before I do all it, now let me introduce you to another question here. All of you understood this. I will do one last type on this, and let's then from there all it will go on. We'll go on from there. Let's see, because we'll run out of time otherwise. We'll run out of time. Let me clear the slides. Well, let me take this slide here. Not about this. Don't bother. Okay, let's try this. Let's understand this. So, for example, if I have a series 1, 1 plus 3 by 7, 3 by 7, 7 square, 7 by 7 cube, 9 by 7 raised to power 4, on and on and on up to infinite terms, up to infinite terms of this series. So you may wonder that up to infinite terms, how do I add it? Simple, you can add it because the numerators are increasing. Now look here, by the time you came here, already you have already 7, already now you have 7 divided by 7 square, 1 by 49. So next time by the time you came here, you have 9 divided by 7 raised to power 4. It has become pretty small. It has become really small by the time you went there. Similarly, when you start going, because your numerator increases here, 1, 3, 5, 7, 9, increases at a much slower pace, whereas here, alright, now here you had 7 power 0, 7 power 0, 7 power 1, 7 power 2, 7 power 3. The denominator increases at a much higher rate. Therefore, the terms towards the end will be negligible. For example, if I write 1 divided by, now 1 divided by, let's say, if I just write a term 1 divided by 10 raised to power 4, negligible. This is negligible because you'll write this as 0.00001. Now that's negligible, and that is what is going to happen with these terms. Now, this is also called as the pattern of AGP. In popular terms, we call it as arithmetico-geometric progression. Why? Because certain terms are in AP, certain terms are in GP. Guys, now let me write 7 power 1. Let me write 7 power 1 is equal to x. Let me write 7 power 1. 1 divided by 7 power 1 is equal to x. To explain this little better, 1 divided by 7 power 1, let me write it as x. That is 1 by 7 is equal to x. In that case, I can write the same s as 1 plus 3x plus 5x square, because 1 by 7 is x. Therefore 1 by 7 square becomes what? That is 1 by 7 whole square. See, 1 by 7 square can also be written as 1 by 7 whole square. 1 by 7 whole square is nothing but x square, because 1 by 7 square is 1 square by 7 square. You can write it like this. Therefore 5x square, this you can write it as 7x cube, or you can write this as 7x cube. The next one you can write it as 9x power 4. Now look at this. What is that I'm trying to say? I'm trying to say that this 1, 3, 5, 7, 9 are in kind of AP. Alright, they're in AP. Now whereas x square, x cube, x power 4 are in GP. Therefore we call it as a arithmetico-geometric progression. What do we do with this? We'll convert this to a partial GP. Idea is what? We convert this to a partial GP. That's idea. That is important, because I should know, okay, given this, what I should do. What is my roadmap? What is my plan of action? Your plan of action is converted to a partial GP. How? You convert this to a partial GP using a common ratio. Hey, what is the common ratio here, my friends? The common ratio is x. Nothing but 1 by 7. Finally, we'll substitute 1 by 7 there. What is the common ratio here? The common ratio is your x. Okay, via common ratio. Via. What is via? Via media is using common ratio. Good. Okay, via media is using common ratio. How do I do that? Simple. All right, now, so all you got to do is multiply this by sx. X is the common ratio. Simply multiply by Sx. All right. If I multiply by Sx, 1x it becomes 3x square. All right. Now this will become all right. Now 5x cube like this. What I do is I will shift and write. Let me shift it and write. Let me shift it and write. So x can come below x. 1x I will write under this. 3x square I will write under this. Nothing, I'm just shifting, I'm multiplying. Of course, I'm multiplying all the elements by x only, but I'm shifting and writing so that evaluation is easy. Evaluation is easy. Okay, what I'm doing it here, I'm writing this as 5x cube. I'm writing this as what, 7x raised to power 4, and so on, infinite series. Now do what? Solve, subtract the second from the first. You have 1 full x here and you have sx here. Therefore, you can write this as s times of 1 minus x is also equal to 1 plus, is also equal to 1 plus 2x plus 2x square plus 2x cube. Likewise, plus 2x raised to power 4. Oh, fantastic. We got it now. We got it now. What did we get? So this is nothing but a GP. I got it as a GP here. The first term is 2x. The common ratio is x. Multiply by x, you get it. Multiply by another x, you get it. Multiply by another x, you get it. Therefore, it has become a GP. Now, this particular portion has become a GP in finite terms. GP in finite terms. Therefore, s times of 1 minus x, s times of 1 minus x is becoming what, my friends? 1 plus. All right, 1 plus. Write the first term because it's a GP up to infinite terms. Write the first terms. First term is 2x divided by 1 minus common ratio. All right, 1 minus common ratio. You got it. Therefore, s is equal to divide throughout by 1 by x. Therefore, you will get this as 1 divided by 1 minus x. 1 minus x plus 2x divided by 1 minus x whole square. What did you do? You transferred this 1 minus x to the other side because I wanted s, not s times of 1 minus x, right? I wanted x. Therefore, you got this response. All right, therefore, you got this response. You got this response. Now, listen, how do I do this shortly? Because this is another very popular kind of question that you get, right? You get this as a very popular kind of question. So, how do I do this very shortly here? Now, listen carefully, my friends. All right, listen carefully. Right now, what was given to me? S. If s is given to me, all right, s is of the form, listen, a naught plus a1 times of x plus a2 times of x square plus a3 times of x cube, like this, up to infinite terms. Up to infinite terms, not infinite, up to infinite terms if it is given. So in which a naught minus a1 is common. A1, this is also common in the first stage itself. Well, it is also common. This difference is becoming common. Then yes can be written as a naught divided by, alright, if the difference is common, the moment you got the difference there, d, you got that particular difference, alright, you got that particular difference in the first stage itself. If you get that particular difference, you can write this as a naught divided by 1 minus x. Some can be written as a naught divided by 1 minus x plus, alright, the difference, whatever the difference you are getting right now, d times of x. Alright, the difference, whatever the difference you are getting, d times of x divided by 1 minus x whole square. You can directly write the sum like this. I want you to remember this. I want you to remember this. Okay, let me tell you what I meant by this. Okay, what was my s, my friends? Here, my s is nothing but a naught. To go there, write it. A naught is nothing but 1. Alright, then you had 3x, then you had 5x square, and so on. Alright, now 5x square, 7x cube, and so on. Okay, the difference here, difference is 2, the difference is 2, the difference is 2, and so on. So therefore, all it now, so what is that you are trying to say? You are trying to say that this is my difference. Yeah, what is this here? This term is nothing but my a naught. My first term is nothing but a naught. Therefore, I can write the sum as a naught is what? 1. Okay, what is the difference? All it now, 1 minus x. All it now plus. All right, plus d. What is the value of d here, friends? 2. 2x divided by 1 minus x whole square. All right, 1 minus x whole square. We can write this result directly, which you also write it here with some practice. You wrote it like with some practice, which you can also write it pretty directly, pretty much directly you can write. Hey, what was the value of x? You can come back and substitute. The value of x was 1 by 7. You can come back and substitute. I just taught you from the perspective of x. That's it. Okay, I also want you to remember this structure. I want you to remember this structure. See, there are some structures in algebra. If you remember them, and these are very popular structures, keep coming in the exam. If you can remember some of these particular structures, it becomes a lot more easier to solve the issues. Alright, it becomes literally a lot more easier to resolve these particular issues. Okay, fine. I guess already I gave as much as inputs possible about this in the last 2 hours. I would rather close, I would close this session here. There is a lot to discuss about the progression, sequences, and series. I just didn't get time to talk about the sequences and series. Let me see, all right, now before your cat comes, if there is a time to talk about sequences and series, I'll come back and talk about sequence and series. But I talked about, all right, some of the important parameters. Whatever the time is available till the cat, I will use this time to give you certain inputs, all right, which will definitely help you. I will try to simplify the inputs and give it to you. But whenever I give the input, you please go back and work a little more on those particular inputs to gain the depth of understanding and gain certain momentum by practice. You please do that part from your side. From my end, I will try and come and clarify the concepts that are required there in the time available. So here we go, friends. All of you stay safe. I'll come back with my lecture. Bye till then and stay blessed.